Hello and welcome to my course Setting Up AWS Infrastructure for Production and Learning Terraform. My name is Sai and I'll be the instructor for this course. Over the next few minutes, I'm going to talk about what this course offers and how it will help you to get a boost in your career. As you all know, AWS is one of the top paying job roles in the current software industry. And you are going to find many AWS courses on Udemy that will teach you different parts of AWS and different services. But none of them actually teach you how it is implemented in a real world scenario and how production workloads are deployed. So I have created this course to help you all learn how to create infrastructure that can deploy production workloads at scale. So let's see what we are going to learn in this course. So here are some of the goals that you're going to achieve by the end of this course. First, you will create the infrastructure from scratch to a finished product which will accommodate any production workload and it can scale to handle any number of customers. Here's the architecture and you're going to create all the components that are there in this architecture diagram. And the second thing that you're going to do is you'll understand the concept of three-tier architecture to host a web application securely in a public cloud. Next, you'll learn the concept of infrastructure as code using Terraform, and this is one of the trending topics in the industry, and this skill will definitely give you an edge in your resume. And last but not the least, you are going to learn how to do DevOps using Slack. As you all know, Slack is one of the commonly used messaging platform in the current industry. Now let's talk about the course curriculum and all the different sections that are that we are going to cover in this course. So first we'll start off by talking about our architecture in the introduction section. And in the network setup, we are going to create our VPC, subnets, and all the building blocks that are required for a production infrastructure. Next, we'll create the application servers. And in this section, you will see how application servers are configured, how to automate your application servers, how to manage your builds in S3, and how you can copy them on the fly to a EC2 instance and stuff like that. Then we are going to configure our application load balancer, and you're going to see how you can serve the application with multiple instances in place, and how you can route your application to different target groups and stuff like that. Next, you're going to create the auto scaling groups. In this section, you will learn how to dynamically scale your applications based on different parameters like incoming traffic, the CPU usage or latency and stuff like that. And we're going to create different alarms and different scaling policies that will allow your application to scale dynamically. And the next section that we're going to do is the DB instances, wherein you're going to set up your security groups to configure your DB servers, and you're going to create a RDS instance. And in the next section, which is the manage and configure DNS, here you will set up your Amazon certificate manager, and you're going to issue a SSL certificate that you're going to assign to your load balancer, which will enable you to serve your application via HTTPS. And also in this lesson, you're going to create a subdomain and through which you can point your application using a DNS. And in the Terraform and infrastructure as code section, you will learn what is Terraform. You'll learn to set up the AWS CLI. You will learn the process of how to write your infrastructure as code from scratch to the end result. And last but not the least, you will see how you can use Slack to perform your DevOps. That is how you can get the visibility of your production infrastructure just by using Slack. That is, like, you can see your scaling activity, you can see your alarms coming in to the Slack, and you can basically expand that idea into anything that you want to uh, get visibility from your public cloud. So I'm really excited to begin this course, and I can assure you that by the end of this course, you will go from AWS beginner to AWS intermediate user. So let's get started. Hello and welcome back. So in this lesson, we are going to talk about the architecture for the production infrastructure that we are going to build by the end of this course. So basically here we are going to take a three-tier approach to host our web application inside our infrastructure. So I'm going to walk you through all the different components in this diagram, and we are going to create each and every component in the coming lessons. So let's get started. So basically in the outermost layer, we have our AWS region. So basically what this tells is in what region our infrastructure is getting hosted, as AWS offers several different geographical locations like US East 1, US West 1, which is North Virginia, Oregon, or EU West 1, which is Ireland. So basically here we are going to choose Ireland as our region. So inside this Ireland AWS region, we are going to create a VPC. Now, a VPC is a virtual private cloud, which is your own private cloud within the public cloud. So basically what this does is it creates your own private space inside the public cloud, and you get to create your own resources which are not visible to other customers of AWS itself. So basically the requirements for this VPC is that you're going to give it a private IP space, which is a IPv4 CIDR block, and what it does is every resources that is created within this VPC gets a private IP from that IP space that you have assigned to it. So inside this VPC, we are going to create our three tiers, which is your private subnets, public subnet, and DMZ subnets. So basically what we are doing is we are splitting this VPC into 6 different subnets, and I'm going to tell you in a minute why we have 6 instead of 3 in the three-tier architecture. So basically we are going to split this VPC into 6 different subnets, and the reason why we have 6 subnets is that we want each type of subnet to be available in 2 different availability zones. So basically what AWS does is it offers us 2 different multiple zones within a region, wherein the zones are also physically separate locations. And the reason why we want in 2 different subnet 2 different availability zones is, even if one availability zone has issues or it goes down, we have our application up and running in the second availability zone. So this is just to make sure that you have your you have high availability to your application, and your application is running all the time. So that's the reason we need 6 different subnets and of 3 different types, and we are going to place it in one of the availability zones. So basically once we create all our subnets, then we are going to go and create our application servers, and what this application server does is it hosts our web application, and that's going to go into the public subnets, and it has its own security groups. And what the security groups does is basically it controls the access between different subnets and different applications. So security groups get assigned to the server that you are launching, and it has different set of rules saying which port is allowed for which traffic to come in and which traffic to go out, and so on and so forth. So we put our application servers inside the public subnet, and then we create the database servers, and database servers go into private subnets, and we have our elastic load balancers, which is where the client would access the application from, and these go and sit in the DMZ. So basically the idea of this three-tier architecture is to make sure that your client can only access the DMZ subnet, which is the elastic load balancer, and from there the communication is only between the elastic load balancer application server and database server. Even the database servers are not reachable by the elastic load balancers. So the only persons who can reach the the database servers are your application servers, and the application servers are only reachable through the elastic load balancers, and your clients can directly access the elastic load balancers. So this way what you're doing is like you're cutting off the direct connection between you your application and your client, and you are having a load balancer to balance your load so that you can have multiple instances running behind the load balancers, and you can scale up or down in the instances, and you can facilitate your deployments easily, and you have a better secure network. And the reason why you have your database servers in the private subnets is that you don't want anyone from outside your network to access the database servers, because it is very critical for any web application out there, as it is the heart of any application. So that's why we want to protect our database servers within the private subnet, and the security groups within these subnets acts as the firewall, which controls the access of who gets to talk to this specific servers. So that's it about this architecture, and in the next lessons we are going to deep dive into each of these components, and I'm going to show you step-by-step process on how to create and what are the settings that we have to apply in order to make sure that we stick to this particular architecture. So that's it for this lesson, and thank you so much, and I hope you enjoy the rest of the course. Thanks. Bye-bye. Hello and welcome back. So in this section we are going to configure our network for the production infrastructure. So what we are going to do is we are going to start off by creating a VPC, and we will create different subnets, internet gateways, and so on and so forth. So let's get started. So to create a VPC, we would need a IPv4 CIDR block, which is basically a range of IPv4 addresses. And why we need this is basically whenever a new resource is created within this VPC, AWS would pick a IPv4 address from this CIDR block and assigns it to the resource that is getting created. So for this infrastructure, we are going to choose 192.168.0.0/19, which is a very big IPv4 space. And what we are going to do is we are going to divide this IPv4 CIDR into 6 different CIDR blocks, and we are going to assign it to 6 different subnets that we are going to create. So the way how I am going to divide this specific CIDR block is that I'm going to use a calculator for this, and I'm going to key in the IPv4 CIDR that I'm going to use here. So I'm saying basically here is that I'm going to use 192.168.0.0/19, and what I'm saying is I need 6 different subnets, which is ABCDEF here, and I'm going to say I would need 256 IP addresses in a specific subnet. I'm just going to copy paste it everywhere, and I'm going to submit here. So basically what this did was it couldn't exactly divide into 256 IP addresses, so it allocated 510 IP addresses, and it has given a mask of /23. So I've copied that information from this table to our slide here. So we have 6 different subnets with /23, which is .0/23.2.20/23, etc. And we are going to use this to create our subnets. So let's get started. So log into your AWS console, and if you are in the console, you can just type VPC and then go to that part. And in this VPC part, if this is the first time that you're visiting this page, you could see that there's already one default VPC created for us by the AWS. So this can be directly used, and we could still go ahead to EC2 and spin up our resources, but we are not going to use this because we want to set it up from scratch so that we have multi-AZ failover, highly reliable production network, and we want to choose like how much IP space, how many IP addresses that are allocated for a specific subnet, etc., etc. So let's get started. So hit create VPC, and it would ask you for a name. I would generally use prod VPC, and I'm going to key in the IPv4 CIDR, which is 192.168.0.0/19. So this is, for now we don't need a IPv4 v6 CIDR block. If you need it, you could just click this and then it would give a IPv6. Amazon would directly give you a IPv6 CIDR block. So for this lesson, we're not going to choose this. And we're going to choose a default tenancy because we don't want a dedicated network, dedicated host machine to host our network. So we are going to hit create, and then this is going to take a few seconds, and once it is ready, you have your prod VPC. Now it's the time to create your subnet. So go here, click on the subnet, and then you can see all these are the 3 default subnets that AWS has created for us, but we're not going to use this. So hit create subnet, and let me pull up that page wherein we have these 6 subnets that we're going to create, and which is DMZ. Let's start with the DMZ. So DMZ, let me make this full screen. DMZ subnet 1, which is going to be a prod VPC, and so we're going to choose 1A and 1B for DMZ, and 1A 1B for private and public. So this is just to make sure that your subnets are spread across different availability zones, so that even one availability zone goes down, you have your system up and running in the other availability zone. This is to make sure that your system, your prod network is highly reliable. So we're going to choose 1A here, and we're going to key in the IPv4 CIDR block, 192.168.0.0/23. Hit yes, create. And then let's quickly create the DMZ subnet 2, and you're going to uh 2.0/23, and once this is done, we're going to create public subnet 1. We're going to choose 1A 192.168. We're done with 2. We need 4.0/23. Create public subnet 2. To choose 1B 192.168.6.0/23. Also make sure that you decide your subnet range beforehand, because you cannot expand these once it is created. You would need to destroy the subnet and then recreate, and this would mean that you would have to terminate all the resources that were in that subnet. So just a heads up, please think about how many IP addresses that you need in a specific subnet before you create. We need now private subnet 1, and we need it 1A 192.168.8.0/23. Now we have private subnet 2 192.168. 10.0/23. All right, so now you have your public, your prod VPC and your 6 subnets ready. So make sure that you follow along with this tutorial so that you don't miss any part, because this is the fundamentals and this is the foundation of your network, and you would be using these subnets and VPC in all the next lessons. So make sure you practice it along with me. So that's it for this lesson. In the next lecture, we're going to configure the route tables and configure the routes between our subnets. Thanks. Bye-bye. Hello and welcome back. So in the previous lesson, we have created the VPC and the subnets. In this lesson, we are going to create the route tables and the internet gateway, which will complete our VPC setup. So before we create the route table and internet gateway, let's just talk about the route tables. Route table is basically a set of rules that would define which IPs can communicate to which subnets and how the routes are propagated between the subnets. And internet gateway is basically allows the resources to be able to access to internet. So we would first create an internet gateway and assign it to route table, so that the resources that were created in that VPC can have a outbound route to the internet. So let's get started. So first of all, log into the AWS console, and once you are here, you can go to the VPC section. So here you've already created your prod VPC and you have your subnets ready. So when you create your VPC, there's a default route table that's been created for you, which is prod VPC route table here. So this is our main route table. So this is like the main route table, which tells us, which defines which IPs can communicate between subnets and what routes can flow. So by default, you just have that all the instances that are created within this VPC, which is our subnet range. I mean the IP space range 192.168.0.0/19. All of them can communicate between each other. So this is fine, but we don't have an internet gateway connected here so that we can talk to the internet. So so for that, we need to create the internet gateway. So for that, you need to go to internet gateways and create an internet gateway. So we are going to say prod IGW, which is internet gateway. Just click yes. Now you have an internet gateway, but it is currently not attached to anything. So for this to work, you need to attach it to a VPC. So we are going to attach it to our prod VPC. So you can select it from this, and then you can hit attach. Now your internet gateway is attached to the VPC. Now let's go back to the route tables. And here in prod VPC, you see that there is no internet gateway attached. So what we're going to do is go to the route section and hit edit. And then you can add another rule. You're going to say we want to allow this from everywhere. So you're going to do 0.0.0.0/0, which is basically everything, entire internet. And then you're going to select the internet gateway that you just created. So let's open this in a new tab and check what is the IP ID of the internet gateway that we've created, which is CEA. And you can see CAEA, and you're going to hit save. So once you hit save, this is going to turn to active. That means that now all the resources within this VPC will be able to access internet because it has a route outbound to internet. So the next thing that we are going to do is we're going to create 3 more route tables, one for each of the subnets, which is like pair of the subnets, like DMZ, one for DMZ, one for public, and one for private. So this is going to be our main route table, but we want to create 3 sub route tables so that we can further have routes configured specifically for a specific subnet. For this lessons purpose, we are not going to complicate stuff. We are just going to create three new route tables. So we are going to call DMZ route table, and we are going to create it inside the prod VPC. And once the route table is created, you're going to edit this route table, and you're going to add first the internet gateway to this route table. This is because you have internet route assigned to the main route table, but this will not this does not mean that every sub route tables that this VPC has also has that access to internet gateway. So we'll have to explicitly assign the internet gateway to the individual route tables that we're creating for the subnets. So once you hit save this, then you'll see that the status has turned to active. Now you're going to go to subnet associations here, and then you're going to add the DMZ subnets to this route table. So all the routes to this 2 subnets would be propagated through this route table. So now you're going to select the DMZ1 and DMZ2 and hit save. So now your DMZ route table is ready. Now what you're going to do is create another route table for the public route table. You're going to choose a prod VPC and you're going to create. And the same thing, first thing you're gonna do is go to the route section and add route to your internet gateway, and then hit save. Go to subnet associations, and you can see here that your DMZ is already assigned to these route tables. Now you're going to choose the public subnet and hit save. Okay, so the last thing that is left now is to create the private route tables. And for the private route tables, we'll not be using the internet gateway. Instead, we'll use the NAT gateways. Basically, NAT gateways are a replacement to the NAT instances, and they are used in private subnets because that way the private subnet instances cannot be accessed from the internet, but the private instances can access the internet without the public IP address being assigned. So in order to do that, first we need to go to the NAT gateways and create a NAT gateway. And also the NAT gateways are deployed individually in each availability zone. So in our case, we have 2 private subnets in 2 different availability zones. So we need to create 2 different NAT gateways. So first thing I'm going to choose is basically you need to deploy your NAT gateway in a public availability zone, because in a public subnet, because the NAT gateway needs a route outside the to the internet, but the private subnets use this NAT gateway as a route to go out to the internet. So we are going to choose a public subnet here. Let's choose the public subnet 1, and we need to create an elastic IP. You can hit create, and it has allocated an elastic IP here. So now we can create the NAT gateway, and then we can close this, and let's create another NAT gateway and choose the public subnet 2, and let's create another elastic IP, and then we're going to create a NAT gateway. Okay, so now we have 2 NAT gateways here. Now they are still getting created, and once they are ready, they'll be in the active state. So the next thing that we have to do is go back to the route tables, and we need to create two route tables now, because the reason we are doing two route tables here is basically your NAT gateways are deployed in each availability zone, and if that particular zone where the NAT gateway is deployed goes down, then your entire service goes down, because they can't be able to access the internet. If your applications are dependent on internet, then those applications would fail. So in order to have a highly reliable infrastructure, we need to have two different route tables pointing to different availability zones. So now let's create the private route table here. Private route table 1. This is going to prod VPC. And inside this, we're going to add a route to our internet, that is, and we are going to choose the NAT gateway. Now we need to be careful of what NAT gateway we choose, because we need to choose the appropriate subnet here. So let's go back to our NAT gateways here, and let's see. So basically, so this is our public subnet here, and let's go back to this guy, the NAT gateway, choose this public subnet, search for this guy. So this is public subnet 1. So let's go back here and name this as NAT gateway 1, and this is NAT gateway 2. So basically what this means is this is public subnet 1, so we are going to choose this NAT gateway 6608 here inside the private route table 6608, and we'll save here, and then we'll go to the subnet association, and we need to assign the private subnet 1 here, because we are choosing the public subnet 1 for the NAT gateway. That way everything stays in the same zone. Okay, so now this is done. We need to create another route table, which is our private route table 2, and this is going to be in the prod VPC. Hit yes, create, and then we need to go to the routes, edit, add another route, and then choose the another NAT instance, which is 844, and hit save. And in the subnet associations, we are going to give it the basically we have to choose the private subnet 2 and hit save. Okay, so now we are pretty much done here in the VPC section. If in case we need to do more modifications to our network infrastructure, then we are going to come back to this section, and that's it for this lesson now. Thank you so much. I'll see you in the next one. Hello and welcome back. So in the previous lesson we have completed most of the network setup, but there is one last thing that I want to change, which is auto enable public IP assigning. So basically for your application servers to be accessible via the internet, they need to have a public IP address. Although you could assign a public IP address when you are launching the instance, there is also an option that you can assign to a subnet saying that all the resources have a public IP address by default unless and until specified not to. So to change that setting, all we got to do is like go to the VPC section and go to our subnets part. So I'm going back to my subnets here, and here what we are going to do is basically select our public subnet, which is public subnet 1 here. Go to subnet actions and select modify auto assign IP v4. So basically you can select this guy and then hit save. We're going to do the same thing to our public subnet 2. And hit enable. Okay, so now that we have these settings enabled, so the next time when we launch our EC2 instance, you don't need to specify that we need to assign a public IP or not. By default, the public IP assigning is enabled. So that's it for this lesson, and I'll see you in the next one. Thanks. Bye bye. So now we're going to go to the EC2 part by hitting EC2 here. And if this is the first time you are visiting this page, then to the left you can see that there is the instances pane where you're going to create the instance here. Just click on instance. Don't worry about if you don't know all the options here. We are going to discuss it in the next coming lessons. So once you go to the instance tab, you have an option. When there are instances created, you would see those instances appear in this part. Right now we don't have any instances in this section, so we're going to create one. So hit launch instance, and basically you need to choose an AMI. AMI is nothing but a base operating system that you want to base image, wherein it can be a Linux operating system or a Windows operating system or any of the custom image that you uploaded to the AMI Amazon's AMIs. So here we are going to use the Amazon's Linux base AMI, which is right here, and you can select that. And there are a bunch of different options to choose the instance type. Instance type defines how much CPU is assigned to that instance, how much memory is assigned, what is the storage type, and how the network performance is going to be, and all these parameters decide which instance type you want. For the testing purpose, we can choose the t2.micro, and also this is free tier eligible, as well as this is one of the least cost instance that you can find on AWS. So you can choose your specific instance based on your computing needs, but for now we are going to choose the t2.micro. Once you select this, hit next, configure instance details. In this section, you are going to specify how many instances that you want to load. We just want one instance, and we don't want a spot instance because spot instances expire once your bidding price changes. Let's talk about that in another lesson. Here the network part is important because we don't want this default. We want the prod VPC that we have created. So we are going to choose prod VPC here, and we are going to choose a public subnet because I'm assuming that I'm creating a application server, so I'm going to host it in a public subnet, which is in EU West 1A. You can choose any other availability zone, but I'm going to go with 1A. And here, if you see, now you can see that use subnet setting, which is enabled by default. This is the reason we have configured our subnet to auto enable IP, public IP assigning. We see that setting getting assigned here. So let's talk about IAM role in another section. This is a very important part. I want to go deep into how we use roles in our production system. For now, I don't want any IAM roles. I'm just gonna leave it like this. And the shutdown behavior I want to stop. I don't want to terminate. No, I don't want the termination protection. I don't want detailed CloudWatch monitoring. We do get the basic monitoring of the CPU usage, etc. But CloudWatch detailed monitoring will give us more details compared to the standard monitoring. And we are going to use a shared tenancy. I don't want a dedicated instance, so we are going to just use a shared. And we want to keep all the network configuration as default and then add storage. So I think for our use case, 8 gigs is more than enough, and I'm going to choose general purpose SSD. You can also choose provision IOPS if you want like dedicated IOPS and you don't want to compromise on the performance of the drive. But for this purpose, we are going to just use the SSD, general purpose SSD. You can add new volumes if you want, but for this lesson, we are not going to add. So let's add some tags. Tagging is really important because this helps us in figuring out what type of instance, what is the purpose of this instance, and it is also used in the accounting purposes to figure out like which product that you are running is to determine the cost of the products that you are running based on the tags. So let's just add some tags to this. Let's say this is name of that instance. Let's say VPC test instance, and always I go with like environment tag just to differentiate between what environment I'm running. Just gonna say prod, and then I'm gonna let's go back here. Okay, and previous. Oh, I was here, so I'm gonna configure security group. Note that we have created a new VPC, but we haven't created any security group yet. So I'm just gonna, there isn't going to be any security group. This is default one, but this is a default VPC security group, but this doesn't apply to this because this is in a different VPC. So we're gonna create a new VPC, new security group in this VPC, and we're gonna say this as test VPC SG, and we're just gonna leave SSH open to the internet, and this is just for the testing purposes. Do not get me wrong, this is just for the testing. We are never gonna leave SSH open to the internet for our production system. So hit review and then you can hit launch. So when you launch, it would ask you to choose a key pair. We can choose an existing key pair. This key pair is like basically a password. It's like a password for your instance that you're creating. So we're gonna create a new key pair, VPC test key pair, and I'm gonna download that. I'm gonna download that in my documents, Udemy, and inside this EC2, and I'm gonna save it here. So now I'm gonna hit launch instance. Now this is going to take a few seconds to launch. You can go to the view instances and you can see that it's going into the pending state, and then after some time it's gonna start and running. I'm gonna pause this video and come back once it is ready. Okay, so now our instance is ready. It's in the running state. Once you select this, you can see that there is an instance ID, its state, and its instance type, and where we launched this instance, and which AMI we used to launch this, and we got our public IP assigned, we got our private IP assigned, and you also get a private DNS if you want to use this internally. Then you can see this is our prod VPC that we created, and these are the different settings that we see here. So we'll stop this lesson here, and then in the next part we are going to connect to the EC2 instance and then see if you are able to connect to the internet or not. Thanks. Hello and welcome back. So now in this lesson we are going to continue to create the connect to our newly created EC2 instance. To do that, I'm going to SSH using the PuTTY software. If you don't have PuTTY installed, you can just go to Google and search for download PuTTY, and then you can probably install it real quick and easy. If you want to use any other SSH software, you are free to use. Now to use it with PuTTY, you need to create a .ppk file out of your .pem file. .pem file is your key pair that you downloaded when you're creating the instance. To create a ppk file, you can download the you can open up the PuttyGen software, and once you have that open, you can hit load and load the .pem file. It's not visible directly here, so you need to check the all files drop down, and then you need to select that and hit open. So once it's open, you can hit save private key. Are you sure you want to save it without the password? Yes, I want to save it without the password, and I'm gonna name it vpc test kp.ppk. So now this is created. Let's see if we have it here. Okay, now we have the vpc test keypair.ppk file. So now you have to open up the putty, not the PuttyGen, sorry. To open up the putty, and you need to key in the public IPv4. So you can hit you can select it from here, copy it, and then you can paste it here, and then you're going to choose SSH, and you're going to go to the SSH part here, and then hit auth and browse the ppk file. So this is the ppk file that we have created. I'm going to select this and hit open. So now you can see that it is asking me to log in. So by default, the Amazon AMI has a user created, which is ec2-user. Once I hit enter, it's going to authenticate using my private key that we have created using PuttyGen, and it has logged in to our created EC2 instance. So this is our first EC2 instance that we have launched here, and you can see all our network configuration is correctly configured because we are able to connect to it via the public IP. So the one thing that we can do is, like, we can try to browse the internet. We can see google.com. Okay, so yeah, we got some response from google.com that it has been redirected somewhere. So that means that our internet is working, our VPC configuration is complete, and we have tested it by creating a new EC2 instance. So that's it for this lesson, guys. So in the next lesson, we are going to deep dive into EC2 part and learn in detail what each and every other option that's available there. See you there. Bye bye. Okay, so now we have completed the network setup section, and let's do a recap of what we have done so far. So we started off by creating a VPC using a CIDR block, which is 192.168.0.0/19. We've then seen how to split this VPC CIDR block into different subnets. We have calculated our subnet ranges, and then we have created our DMZs, our public and private subnets, and then we created our internet gateway, and then we have configured our route tables by supplying an outbound rule outbound route to our internet gateway so that our instances can talk to the internet. And then we booted up our first EC2 instance. In this part, we have seen how to connect to our EC2 instance, and what are the different parameters that it takes to boot up a new EC2 instance, and so on and so forth. And then at the end, we have tested the connectivity of internet by going into the SSH, by doing an SSH into the instance, and then trying to visit a website, and then it all worked out well. So that's it for this lesson, and you're doing a great job. I'll see you in the next section. Thank you. Bye-bye. Hello and welcome back. So in this lesson, we are going to create an IAM role for our production EC2 instances. I feel there's like two reasons why we need to use the IAM roles. First thing is that we need a role so that we could assign permissions to our EC2 instance so that the instance can access some of the resources within the AWS ecosystem. For instance, if if your production instance needs access to some S3 bucket to download some data or some code, anything it might be, then you could just give the role some permissions, and then the EC2 instance would automatically be able to access that specific resource. And the second reason why we would need an IAM role is that this would avoid embedding of our security credentials within the instance, which is not a good practice. And and also it is kind of secure, as AWS will handle the permissions within behind the scenes. So let's get started. To do that, you need to log into your AWS console, and you need to go to the section IAM. So go to the IAM section, and under this hit roles here, and then you can start creating a role. Roles can be created for different services, but we are talking about the EC2 role, which is you're going to assign it to your instance. So you need to select EC2 here. So hit select EC2 instance, and then if you can see here, allows EC2 instance to call AWS services on your behalf. So this is what we wanted to do. So hit select and then hit next. So by default, I don't want to give it any permissions because I want to give it permissions when it is required. I would always follow the least privilege access method, wherein you just give the permissions that are required by the instance. So right now I don't know what permissions I need to give it. So once we get to that stage where we think that okay, we need something, some permissions so that we could access it, then I would give permissions. So for now, I don't choose any policy here. Just hit next review, and I'm gonna give it a name. I can call it instance underscore role underscore prod. This can be anything. Primarily you need to mention prod so that you can distinguish between your other environments here. So you could say allows EC2 instance to call it for production instances, just to be clear. Then hit create role. Okay, so now your role is created, which is instance underscore role underscore prod, and anytime you want to give it some permissions, or you can just come to this section, and then you can just to attach policy if it is already created. If not, then you can go to the policy section and you can create a new policy and give granular access to the resource, and then you can just attach that policy to your role, and your EC2 instance will pick it up instantly, and then it should be able to access that specific resource. So that's it for this lesson, guys. I'll see you in the next one. Bye bye. Hello and welcome back. So this will be the part 1 for configuring our application servers. So let's get started. So first we'll need to go to the EC2, and then the idea here is to let's try to set up a EC2 instance, and then we'll try to configure our application within that EC2 instance and try to access it using the public IP, so that this will ensure if our network setup is done right, and this will be our first step in configuring our application servers. So let's get started. So once you're into the EC2 section, you can go to the instances, and then you can hit launch instance. And for this purpose, you can, in your production instance, this might be a completely different scenario, but usually you could choose your own Linux flavor, or you could go with the Windows base instance here. For this lesson's purpose, we are going to choose a Amazon Linux AMI, and this is basically an idea of like how an application server should be configured. So yeah, I'm going to use a Amazon Linux AMI. So I'm going to choose the t2.micro. Again, this is based on your computing needs, so you need to choose it wisely. For this, I'm going to choose t2.micro. I'm going to hit configure, and here I'm going to choose the VPC that we have created, which is our prod VPC, and I'm going to put it in our public subnet 1. So like discussed in the architecture section, wherein we have our application servers hosted in the public subnet. So I'm going to choose the public subnet while launching that EC2 instance. So coming back here, and I need a public IP because I need to check if I'm able to access our application via this or not. I'm going to choose the instance role that we have created, which is instance role underscore prod, and then I'm going to choose my shutdown behavior as stop. That is, whenever I shut down, it just stops and it doesn't terminate. And I don't need an accidental termination here. This makes sense when you're configuring your database servers or something like that, which you don't want to like accidentally terminate. And I don't want any detailed CloudWatch, so I'm not gonna check that. And in some cases you might need to assign your own private IP address here. If you don't need to specify something, then AWS will automatically assign one from the subnet IP space. So that's it in this part. I'm going to go to the storage section. I think 8 gigs for this application is more than enough. Then I'm going to hit delete on termination. So this is one of the important thing, because like what happens is, if you don't check this box, if you stop your instance, then your drive, if you terminate your instance, if you don't check this box, then your drive is left behind, which I don't want, because you'll be paying for the volume separately, and the instance cost is separate. So make sure that if you don't want your EBS volumes to lie around even after they are terminated, then please do check this. And if you need more space, you could always add more space here. So I'm gonna hit next, go to add tags. It is always a good practice to tag your instances, because it is easy to find. It is sometimes easier when you want to build with like your production instances separately and your QA instances separately. I mean, it is easy for you to sort when you have tags around your instances. So I'm gonna give it a name first, because I want to check, I want to know what that server is doing, and then I will give it an environment tag, so that I can distinguish between different environments. I'm gonna give it like application server 1. It can be I'm gonna give it a test, because I'm gonna test this, and then we are going to reconfigure this in some other manner, which I'm going to discuss as and when we go into the lesson. So I'm going to give it a test name, and then I'm going to give it environment as prod, and then I'm going to hit next, configure security group. So basically there is we'll create a new security group here, because we want to use this in our upcoming lessons too. So I'm gonna give it like public security group, and this is applied to all the application servers. And here by default, for now, I mean, like to configure our production server, I'm gonna let this SSH open to my IP address. So to get that, you could always go to your PowerShell, and you could always do ipconfig. Then you would get an IP address that you're going to key in here, so that okay, so looks like my IPv4 here is 10.0.0.104. For the ease, to make this more easy, let's just keep it open to internet, and we are going to close that down anyways when we finish up our setup. So, and one more thing we need to add is that once we finish our setup, we want to access the application server or on port 80. So I'm going to leave the TCP port, which is like HTTP TCP port 80, and I'm going to take the incoming traffic from everywhere. So this is it that is required as of now. So I'm gonna hit and always give it a name prod so that you know that it is a production security group. Hit review and launch, and yeah, we've chosen the Linux AMI, we've chosen the instance type t2.micro, we have created a security group, and we have given it a bunch of rules, which is saying these are incoming rules, by the way. If you have something open for incoming, then it would automatically have outgoing open for that, those particular things. And yeah, so we have given it some tags, and we have some storage here, and these are all the instance details. That once you confirm everything, then hit launch. Now here we need to select the key pair to launch. In the as in the previous lesson, we have created this VPC test KP. I'm gonna use the same one and hit launch. So this is going to take a couple of minutes. So I'll stop the lesson here, and then I'll continue back once our instance is ready. Thanks. Bye-bye. Hello and welcome back. So now that our application server is up and running, let's try to connect it via the PuTTY or any other SSH that you have. So let me open the PuTTY. Okay, now I have my PuTTY open here. I'm gonna need the public IP here, so I'm gonna copy the public IP, and then I'm gonna paste it in the IP section here. Then I'm gonna choose SSH. The next thing that you want to do is like select the SSH here, open it, then you have auth section, and then you're going to browse for the PPK file that you've created. I've shown how to create the PPK file in the previous lesson. So I'm gonna just use the same private key because this is the same key that we have chosen when we are launching the EC2 instance. So I'm gonna hit select this and open, and then I'm gonna open it. So you should get a screen like this, and then you can just hit yes when you get a pop-up. It came into the other screen, so I just had to click yes there. So if it appears in your case, you just need to hit yes there, and then you're going to log in as a EC2 user. This is the default user that's created when you use a Linux AMI. So hit enter, then you should be able to enter your system. So the first thing that I'm gonna do is like I'm gonna run a yum update, sudo yum update. So this will make sure that all the latest patches or everything is added here. So I'm gonna hit yes. So I'm gonna open a notepad and note down all the steps that I'm doing so that we can write a script to automate these kind of things. So the first thing that we did is sudo yum update and hit -y because we hit a we did a -y there. I'm just gonna pause until this update is finished. Oh, it's already done. So okay, so the next thing that we're gonna do is like we're gonna install a HTTPD server, which would enable us to host any PHP or any of those. So let's install both HTTPD and PHP. So that's going to be sudo yum install HTTPD, and you could also specify PHP here. This is just for a demo purpose, and the setting up of an application server completely depends on scenario to scenario, wherein like your scenario might have a Node.js server running, or you might have a Windows server hosting IIS server hosted on a Windows instance. This section, like this part, differs in everyone's scenario. I'm just giving you a general idea of how it is set up here, so that we can build our infrastructure on top of it. So I'm gonna hit enter here with -y, and I'm gonna write down the same thing here. I did sudo yum install httpd and php-y. Okay, now our sudo yum the httpd and php are installed, and the next thing that I'm gonna do is like I'm gonna start this httpd service. So I can just do sudo service httpd start. So once this is done, your http server starts. So I'm gonna note down the same thing here, service. I'm gonna do sudo service httpd start. Now one thing that we need to do is like check if anything is running on our port 80. So all we gotta do is like copy this public IP, open a new tab, paste this. Wow, so our base server is installed now, and then there is a default landing page that is created by when we install the httpd and php here. We can confirm that this is working by going to the directory of cd var www and html, and by default there's nothing here, but we could create something like index page. This is just a text. I'm gonna create index.html here, and okay, so let's bump up the privileges here. I'm gonna run the same command again, index page. I'm gonna do index.html. Oops, we just need to do echo in front of it. Okay, so now that we have created this index.html, which should be by default accepted. Let me refresh this here. Okay, cool. So I do see an index page here. So the idea here is that we could host our application here, which we could copy from the S3 and then put it here, so that whenever we put up a new instance, we run this script, and this would just copy the application from the S3 and then put it in this place, so that our application is ready and configured. So I'm gonna pause this here, and then I'm gonna set up the in the next lesson I'm going to show you how we could store our application in the S3 bucket, and how we would copy that directly to the instance and configure it. Thanks. Bye bye. Hello and welcome back. So let's continue from where we left off. So we would create a sample application here. It's not a great application, but it's just like a small HTML file. In your case, it might be your actual application. So I'm gonna give it a name, prod application _prod, and here I'm going to create some new files. For that, I'm gonna open up, create a new text document, and I'm going to name it
.html. Let me change it to index.html, and then yeah, I want to change it, and I'm going to open with Notepad, and I'm gonna say on my title bar HTML, and I was gonna say in body, I'm gonna say this is our production application, and I'm gonna save it. I'm gonna go back here, and then no, actually I would just create a zip file out of the contents here. If you have multiple files, you could just create a zip file here. So I'm gonna create a compressed zip folder, and I'm gonna name it application underscore prod.zip. Okay, so the next thing that we're gonna do is like we'll create an S3 bucket, and then we are going to put this application onto the in the bucket, and then try to download it via the EC2 instance. So to do that, let me go back to the AWS console. I'm going to open a new tab. Here I'm going to go to the S3 bucket, and then the first thing that I'm going to do is like I'm going to create a bucket. I'm going to give it a name, S3. Let's call it this is like our big prod company. I'm just giving it a random name, and these are unique, and these should be like this should follow a URL format, so we cannot use underscores or any uppercase letters. So I'm gonna change it to big prod company dash, and I'm gonna say builds dash prod. Okay, and we are going to choose the Ireland because we are building our infrastructure in Ireland, so it makes sense to have it in the same region, and then hit next. You could always play around with like the requirements that you want here, but I'm gonna go with the default settings, and I'm not giving any permissions here right now because I want to handle it via the role, and then I'm just going to hit create bucket. So once your bucket is created, you could always search here my big what is that, big prod company buckets. Okay, so here I'm gonna create a folder called builds, and then I'm gonna save it, and inside this I'm gonna upload my file, which I'm gonna drag and drop from here. So this is readily available. I'm just gonna go with the defaults and upload it here. Okay, so now our application is in the S3. The next thing that we are going to do is like download this application from the EC2 instance itself, and then try to put it in place so that it is directly accessible from the internet. So to do that, we need to go back to the console. Okay, before we do that, we know that we don't have any permissions assigned to our role, so we're going to go back to our IAM section and then add some permissions so that our EC2 instance can access that specific S3. So I'm gonna go here and go to our roles section. No, I'm gonna go to I'm gonna go to the roles section, and here I'm going to go to the role that we have created, instance role prod, and inside this I'm going to attach a policy. For now I'm going to assign S3 read-only access. Okay, we are going to create our own policy so that we give only granular access. So we're going to go to the policy section here, and then we'll hit create policy. So we can actually use this visual editor, or we could directly go and paste the JSON here. So what I'm gonna do is like I'm gonna go to this link here wherein it shows how to specify permissions in a policy, and I'm gonna copy this section here. So I can just copy this JSON here and go to the IAM console, and then I'm gonna paste it here. So I'm just gonna change this as like this can be any ID. You could put in anything here in the SID section. I'm gonna put in our S3 prod builds access policy. I'm just making that up here, and in the actions I'm actually going to give S3 star, and I'm gonna take this off from this part here. And here I don't want to give it to all the buckets. Like if you see in this document in the upper part, you have this section here where you can specify the bucket. So I want to specify the bucket that we have created here, and I'm gonna give permissions to all the folders, I mean all the objects within that bucket. So I'm gonna copy this part here. Why doesn't it allow me to copy? Okay, so I'm gonna copy this part here. I'm gonna paste it. Okay, so now that you have pasted your bucket name here, all you gotta do is like key in /star, and then I'm gonna copy this part and paste it back again, and then I'm gonna remove this. So what this means is like you have access to this bucket and all the contents within this bucket, and I'm gonna hit review policy, and then I'm gonna give it a name. So the name that I'm gonna give it is policy dash S3 access S3 builds access prod, and you could just say policy used to give permissions to prod instances to access the builds, and you can just hit create policy. Next thing that you want to do is like search for your policy that you created, and you're going to select this here, and then you're going to attach it to the instance role that you've created. Something happened here. So I'm going to go to attached entities, hit attach, and you can select the role that you've created, which is your instance role prod, and then select here and then hit attach policy. Now you should be able to access the your application within the the application zip file from which is present in S3 from the EC2 instance. Okay, so now I'm going to go back to our SSH terminal here, and then I'm going to execute some AWS CLI command to copy the application from S3. So let me try AWS S3 CP help. Let's see what we get back. Okay, so we have that command, and then we could use we could use something like S3 CP this command, and then specify the local zip file name. So we're going to try that, and so I'm back here. We're gonna do S3 AWS S3 CP, and we're going to give in the bucket name here, which is our this bucket here. So I'm gonna copy this back again and paste it here, we have builds and slash application underscore prod dot zip, and my local file would be application underscore prod dot zip. Okay, now let's check it here. Now we have our application prod dot zip, and what I'm gonna do is like unzip that in this same directory. And before that, I want to delete the index.html that we have created before. So I'm gonna rm-rf index.html. Now that should be gone, and now I could just do unzip application prod zip, and you should get back your index.html here. Now you can get rid of your zip file from here, so you could do rm-rf application prod. Now your zip file is gone. Now all you have left out with is the index.html that you have downloaded from the S3. Now let's go back to the test page and see here. Now you should see this is your production application. So now what we have done is like we have put our builds into the S3, and then we have downloaded it via the EC2 instance, and we have configured it in the right place so that our application server picks it up. So now let's take a note of all these steps that we have done here so that we could automate all this when we boot up a new instance. So now you have this thing installed. After that, we want to start the HTTP service at the end. So before that, what we did, let's go back here. So we did navigate to this path, which is let's take out sudo in front of this and put sudo su, and then here what we're gonna do is like we're going to navigate to that path cd/var. Let me check where we are. We're in the PLT. Okay, we are in the cd/var/html. Oh no, there's www here, and inside this what we did was we did a S3 copy here, which is going to be, just want to copy paste that command. And I'm going to select this part. Oops. Copy it here, and I'm going to paste it here. And next thing that we did is unzip application underscore prod dot zip. The next thing that we did was rm-rf application underscore prod dot zip. Okay, so these are the steps that we have done to configure our application server. So in the next lesson, what we're going to do is like boot up a new EC2 instance, and we are going to run the script automatically, and once the instance start, you should be automatically able to see our application up and running. So I'll see you there. Thanks. Hello and welcome back. So in the previous lesson, we have configured our application server by running a bunch of commands and putting our application onto S3, downloading it via the AWS CLI on the EC2 instance, and then we have configured our application server. So in this lesson, what we're going to do is like we're going to do the same thing, but we're going to run this as a script so that we don't have to do anything manually. So when your instance boots up, your instance should be up and ready, and it should be serving your application right away. So these are the steps that we have performed in the previous lesson. So the one thing that it is missing here is the shebang. So I'm just going to add that bin slash bash, and I'm gonna hit launch instance. I'm going to select the same Amazon Linux AMI, then t2.micro should be good enough, and then I'm going to choose a prod VPC, public subnet 1, and then I'm going to, I can just choose enable here. I'm going to choose the role, instance role prod, and here in the advanced details now we want to run the script. So you could just copy paste your script here, and then you can put it here. So now what this does is, like, this is going to run run this script as a part of user data. That is, once the instance starts, this script is run, and you should be able to access your server right away. So I'm gonna hit next, and then I'm gonna go to here. I'm gonna give it a name tag, application server test 2, and give environment tag, and then I'm going to choose production here, hit next. I'm going to choose the security group that we have created, next, and then hit launch. I'm going to choose the same key pair and launch. Okay, so we have our application server getting created here, and once this goes into the running state, then we should have our application being served when we hit the public IP in the internet. So I'm going to pause the video now, and I'll continue once the application server is booted up. Okay, so now our application server is up and running. Now let's see, let's log into the party session and then check if our code is present in the even before doing that, we could just verify it by going to the public IP here and then browsing it here. So if I browse this, you should be able to see our production application up and running. So we have now created, configured our application server, and we have automated it. That is, like, we have it up and running without any human interference. So that is really good. So that's it for this lesson, and in the next lesson we are going to see how this is hooked up to the load balancers and stuff like that. Thank you so much. Bye bye.
So this will be our end of the section for application server setup, and let's do a quick recap of what we have done so far in this section. So we started off by creating IAM roles, and we booted up a new application server using this IAM role, and in that process we have also created a public security group which had rules specifying what inbound connections are allowed and what outbound connections are allowed, and by specifying different ports. And we have installed PHP and HTTP server on the EC2 instance, and then we created a sample application, a hello world web application, and then we have stored that application in S3, and then we downloaded that application to the EC2 instance by installing the AWS CLI, and then downloading that build directly onto the server. And then we have automated all the process that we have done manually by supplying the steps in the user data. And I think we have covered a lot of ground in this section, and you should be proud of yourself for coming along so far. And I'll make sure that I keep all the next parts even more interesting and more information that you can get out of the next section. Thanks. Bye bye.
Hello and welcome back. So in the previous lesson, we have configured our application server by using the user data script, and we have launched that instance in the subnet, public subnet 1. And in this lesson, what we are going to do is like create the same server in the public subnet 2, because if you look at our architecture here, excuse me. So if you look at our architecture here, we're going to have application server in both the availability zones. I mean, like in the previous lesson, we have created it here in the availability zone 1, and in this lesson, we are going to do the same thing in the availability zone 2. And once we have the two applications servers in both the subnets, then what we are going to do is like create a load balancer, and then we are going to register these two instances in the load balancers, so that whenever we access the load balancers, the traffic is distributed between these two application servers. Okay, so let's get started. So to do this, first we're going to go back to our console. We'll go to the EC2 section. Once we are here, let me show you one trick that we could use. So we could say, let's say if you want to create the same server, if you want to create a duplicate of the server, you could just right click here and you could say launch more, like this. So we want to keep our AMI the same, we want to keep the instance type the same, the security group same, and the one thing that we want to do is like we want to change where this instance is getting launched. So we'll go to the instance details, go to the edit instance. Instead of public subnet 1, we are going to choose public subnet 2, and everything else would be same here. And to differentiate it from the previous one, we could just do here like AZ and then say 2, just to differentiate between our previous server and this server. We're gonna keep the application name same, because technically it is the same application, so we'll keep it the same there. And then we are going to select the public security group that we have created, and let's double check whether our user data is present here or not. Go to the advanced details, and our user data is here, and then we'll check the storage. We have everything here, and then we would launch this using the same key pair. Okay, so the launching of this server would take a few minutes. Let me pause this until then. Okay, so our application server is now running. Let's test this if it is configured correctly by browsing its public IP in the internet. Okay, so this is our application that we have configured. Okay, so now you might be wondering, now that we have two application servers, and how would I distribute my traffic across these two servers? Well, to do that, we are going to use the elastic load balancers. So elastic load balancers are a very good way to handle your traffic, because you get a lot of details from the load balancers, such as like how much traffic is coming in, how many number of requests are coming in, what's the average latency, what is the number of 4xx or 5xx errors that are getting returned from your servers, those kind of details. And it also has different CloudWatch monitors that you could configure, and you could tell your auto scaling groups to scale up the servers if there is any significant amount of load that is coming into the load balancer. So and also you would get one DNS from that elastic load balancer, which you could configure in the Route 53, which we are going to see in the future lessons. But so you'd get one DNS endpoint, and then once you browse that DNS, your load balancer would decide which of the servers to pick based on the load, and then it would send the request to that particular server. So let's get started. So what we're going to do is like go to the load balancer section here, and you can hit create load balancer. Okay, so now that we are here, we have three different options to choose from for creating our load balancer. So we have a classic load balancer, which is a previous generation one. This will do our job fine, but we're not going to use this because this is kind of old. Then there is a network load balancer, which is used when you need ultra high performance in your network, and if you ever need static IP addresses for your load balancers, and you can go with the network load balancer. And the third one is the application load balancer, which is the most commonly used nowadays, and this gives us a lot of flexibility in how we configure application how we configure our applications interaction with the requests that are coming in. So this is generally used in microservices approach when you have a old monolithic URL and then you have new services coming in, and you don't want to group them along with the same monolithic application, but instead if you want to split it into a microservice wherein you can have /v or some other version number and then point your new applications to a different target groups. So this is kind of use case for most of the companies out there. So this is very widely used nowadays. Let's see how the application load balancers are implemented by going to this diagram here. So on the top we would have an application load balancer, and every application load balancer would need a listener. A listener is nothing but where you want your clients to access the load balancer at. That I mean, let's say if you want to serve an application at port 80 and 443, which is HTTP and HTTPS, then you would have two listeners. One is for HTTP and one is for HTTPS. So whenever your client pings your www.example.com, then they come to the load balancer. If they come on HTTP, then they go to this listener. If they go to HTTPS, they go to some other listener, that kind of stuff. So what you do is like you have a listener, and every listener there are set of rules that you can apply, and a listener can take a decision on like which target group it needs to go to. So let's say you have a big monolithic URL wherein some example.com, and you have some service 1 and service 2, and you want to see you want to use the same URL, and you want to direct service 1 to one set of target group and service 2 to another set of target group. Then you could have a rule saying a path based rule in the listener itself, which would control if the path matches service 1, then go to target group 1. If the path matches service 2, then you could go to the target group 2. So once you configure listeners, then there are target groups itself. So what is a target group? It is nothing but a grouping of targets. Targets can be anything. It could be your Docker containers, it could be instances, like our application servers itself will serve as a target here. So basically what we are doing is like we are grouping a bunch of targets and creating a group out of it, and then you have a health check, which checks if the target is healthy or not. So let's say here you have a bunch of application servers hooked up to your load balancer, and you want to know and you wouldn't know which one is healthy, right? So you want to create a health check URL which is checked by the target group with a certain interval that you are going to configure. And what it's going to do is like it's consistently checking for the health, and if ever it doesn't get back the response in a certain amount of time and for a certain number of times,
then what it's going to do is like it is going to deregister that target because it is unhealthy, and it is going to tell the autoscaling group, if we hooked up the autoscaling group, to boot up a new target, and that's going to give us a healthy new target, which would make sure that our application is running as expected. So so this is what we are going to do. We are going to create a load balancer, and within this we are going to create the listeners, and then we are going to create the target groups, and we are going to point our health check URL as well inside this, and we'll also be creating a new security group for the load balancer itself, like we created for our application server. So there's okay, so let's get started, and I'll clear out some other doubts if I feel like if there's something important that I need to mention here. So let's jump back to the EC2 console here. So I'm going to choose the create application load balancer, and then I'm going to give it a name. So I want to give it a name, my big company ALB, which is application load balancer, and prod. I'm gonna just put in like application. This is just, I'm making it up, can be anything. I want this to be internet facing because we want our clients to access it. If for some reason you want a load balancer that handles just an internal application, then you could choose an internal one, then it is not accessible externally. And I'm going to choose IPv4, and we could have multiple listeners like we have done here, but for now we are going to choose just the HTTP because we are yet to configure our certificate manager for HTTPS, so I'm not going to do that right now. And then here we need to choose the availability zones where your application load balancer is hosted. So let's go back to our architecture diagram itself. So here you can see that we have elastic load balancers in both DMZ AZ1 and DMZ AZ2. So we need to select DMZ subnets in both the availability zones. So that's what we are going to do it here. So we are going to go to the EU West 1A, and inside this, oh no, we need to select our prod VPC, and inside 1A we need to choose the DMZ subnet 1, and inside 1B we're going to choose the DMZ subnet 2. So these are the two subnets that we are going to host our application load balancer in, and we'll just give this a name, and I'll copy paste the name from here. And the most important thing is I always give the environment tags because it is easy to figure out which environment load balancer that we are looking at. So here we are going to create a new security group because we don't want to use public SG because that's meant for the application server. So we are going to create a new one, which is going to be external ALB SG. Oh no, we'll just call ELB SG, and we'll just call this as prod, and we'll just say load balancer SG for load balancers. And what we are going to do is like we're just going to say that we are going to allow port 80, which is HTTP from everywhere for now, and then we'll fine-tune these security group rules in the next lesson. So just hit next. So now we are going to create a target group, which is this part. So what I'm going to do here is like I'm going to select the new target group. I'm going to give it a name. Just going to paste in that one, and instead of this I just give target group. I'm going to choose protocol HTTP port 80, and I want to choose the instance, and I'll just give the path of the slash, which is like directly we could be able to configure it. I mean, like we could directly use the root URL for our health check.
Okay, so the next thing that we have here is like advanced health check settings. So here you could specify what's the frequency of your health check, and how long you want to, what's the maximum timeout that you want to give for that health check, and how often you want that health check to be checked. So and what is the threshold? Let's say if you give 5 as your threshold, that means it would wait for at least like 150 seconds before it goes to healthy. And if it sees the unhealthy, I mean, like if it doesn't get back from the health check for 2 consecutive period of time, then it is going to just deregister it. I feel this interval is quite long, so what I'm gonna do is like I'm just gonna give it like 15, and I wanna go the timeout for 14, so we have 1 second in spare here. And then we are looking for a 200 success code. So I want to do healthy 2 and then unhealthy 5, so that if something goes wrong, I don't want my instance to get deregistered very quickly. If there is some small glitch, then I don't want that to like take out my instance from the service. So the next thing that we are going to do is register the targets. So like discussed here, so our targets would be our application servers. So I'm going to choose our 2 application servers that we have created in the previous lessons, and we need to do add to registered, and then next hit review. So inside review we have our name, we need this as internet facing, we have listener port 80, and this is the IPv4 in our prod VPC, and we our subnets. So the next thing is we have created a new security group, and we have created a new target group, and we have configured our health check settings here. Then I'm just going to hit create. Okay, so now our application load balancer is created, and what you'd get, oh, it's still in the provisioning state, by the way. So in the meanwhile, let me explain you what it gives us. So by default it gives us a DNS name which you can directly browse. So in the earlier lessons, what we did was like we were browsing the application with the public IP of our instance itself. So now what we could do is like we could use this DNS, and the request would come to the load balancer, and load balancer will figure out which application server it needs to hit, whether in 1A or 1B, and that completely depends on the traffic. And basically load balancer will try to balance the load between 2 application servers that you have configured here. So that's one thing. And then you have your listeners. So we have our HTTP listener that we have created, and by default there is no rule. So by default everything that comes in port 80 is being forwarded to our target group that we have created. So I'm going to go to that in a bit, and you could add new rules. Like I said, you could have path based rules, or you could have host name based rules. So if you want to add a new rule, you could just go here, add a new rule. You could say insert rule, and you can choose based on the host header or the path pattern, and then you could say forward to a specific security group. If you have multiple security groups, multiple target groups, then you would see it here. So we don't want to create a new rule because we just have one application being hosted in that server, and I want to forward everything to that. So I'm going to go back here, and then you have your monitoring. So monitoring gives us a lot of details on like what's the average latency across all the target groups, how many number of requests are coming in, and then the average latency it gives, like it goes up to all the way up to 2 weeks. So you have that data coming from the CloudWatch metrics, and then you have how many rule evaluations are happening on the fly, and then you get back the 500s that are returned by the server, the count for the 400s, count for the 500s from the ELB, count for the 400s from the ELB, and then you have 200s success code that are getting written back. So this is a lot of information that is generally used in a production network, wherein this helps us to answer a lot of questions in case of there is an outage, or if a customer comes back and says that they are facing huge latencies, then you can come back here and check what's happening here. And you could also configure alarms saying that if there is any high latency that is happening, please notify me via email or any SNS topic that you could configure here. So this is in the load balancer level. I mean, like, you can have multiple target groups, and you could also get individual metrics for that specific target group that we are going to see in a bit. So I'm going to go here, listeners, and then I'm going to open up our target group. So we've created our target group as well. So here you have the target groups, targets, which are our two applications servers, and they are in the status of healthy. That means that they are working fine and they are passing the health check that we have configured here. And you could also get the individual metrics here, that is like how much traffic is coming into this specific target group and what is the average latency from this specific target group. So you'd get the same amount of details that you have from the load balancer level as well. So now let's go back to the load balancer and see if our if it turned from the provisioning state to the running state. Let me just refresh. Okay, now it is in the active state. That means that we could directly use our load balancer. So to check if it's running, all you got to do is like copy the DNS name from here and paste it in a web browser, and you should see your application returning the response. Okay, so this is our response from our application server. That means that we have our load balancer taking in the traffic, and then it is figuring out which application server to go to, and our application server responded with a response, and then it throws back to the client, and that's what we are seeing here. So we have configured this flow. We haven't configured Route 53 yet, but we have client going through our internet gateway, going to Elastic Load Balancer, and then going to public subnet, processing it, coming back to DMZ in load balancer, and then sending it back to the client. So far we have achieved that. So I think we are pretty much good in the application load balancer part. In the next lesson, what we're going to do is like we're going to clean up the security group that we have created, the DMZ security group, and we are going to add in few more rules that would restrict the traffic flow between the application servers and the load balancer servers. So I'll see you there. Thanks. Hello and welcome back. So in this lesson, we are going to clean up our security groups that we have created in our previous lessons. The security groups were public security group and external ELB security group. So what we are going to do is like we are going to put in rules so that the traffic on the load balancer can only have incoming traffic, can have incoming traffic from everywhere, and the outbound traffic that is going out of the load balancer should be only able to go to the public subnet, and the public subnet should only be able to receive traffic from Elastic Load Balancer on port 80, and this is going to control who is going to access the application servers, because we want to cut the client's interaction at the Elastic Load Balancer levels, and even if the client gets hold of the IP address here, he will not be able to ping that IP address directly from the browser like we did in our previous lessons. So let's get started. So to do this, we'll go to our AWS console and we'll go to the EC2 part here and hit the security groups. So first let's go to our public security group and let's see what rules we have in here. So in inbound we have port 80 allowed from everywhere. So we were able to access our application server, which is our test application server. With our public IP we were able to access it and we were getting back the response. So what we're going to do now is like edit this rule, and we are going to say allow traffic for the IPv4 and IPv6 space. Let's take out IPv6 because we are not using it in the load balancer itself, so you'll not get the IPv6 traffic here. So we are going to have IPv4 traffic coming from everywhere. So instead of that, what we are going to do is like we are going to put in the security group here. So we'll say external security group ELB-SG. So what we are doing is saying is like allow traffic that is coming from resources that have this security group attached. That is our load balancer. So we could have a small note here so that it's easy to figure out which rule is configured for what purpose. So for external ELBs, and we don't need SSH here, so we are going to take this off here, and then we are going to hit save. So now what is happening is, if you go here, this worked in the previous time, right? Now if you refresh this is going to time out, because now you have cut the you have put in a role which cuts out the traffic that is not required. But if you go back here to your load balancer URL, you'd still be able to access the same application. You see this is working here, but this is not responding and it is failing here because now you have restricted the traffic to be only coming into the application servers from the load balancers itself. You cannot access it directly. So now you have cleaned up the application, the public security group, but there's one more thing that is left. So here, if you have, if you see here in the load balancer, you get all traffic in. I don't want the IPv6 here, so I'm going to take this off. So you have in your inbound, you have everything is going in, but the traffic that is getting generated from your load balancer should be only be going to the public subnets, but not anywhere else. So you don't want your load balancers to access some other locations. So you're going to edit this rule, and you're going to say that you want HTTP traffic to be going to public security group. You should be able to let's just copy the public security group here, VPC, not the VPC ID, security group ID here, and then go to edit. You're going to change this to HTTP, and going to put in the security group here, and you're going to say traffic flow to application servers, and hit save. So now you have your security groups cleaned up, and you have restricted the traffic flow to the application servers directly by using the public IP. So this is according to our architecture, and that's it for this lesson. We'll revisit the security groups once we create the database servers in the private subnets. Then we'll clean it up again based on like what rules we need at that point of time. So that's it for this lesson. Thank you so much. Bye bye.
So this concludes our ALB setup section, and let's do a quick recap on what we have done in this section so far. So we started off by creating our second application server, and then we have discussed the concept of load balancing, and we have chosen the application load balancer for our scenario, and then we discussed what are the different parameters that the ALB has, like listeners or the target groups and listener rules and so on and so forth. And then we have created our security groups for our DMZ subnet, and then we have assigned it to our load balancer. We have hosted our application load balancer in our DMZ subnets. We have created our target groups. We have created the listeners, and then we have tested. We have attached our the application servers that we have created in the previous lessons to the load balancer, and then we tested the connectivity by browsing the DNS provided by the application load balancer. So I really enjoyed this section because it's kind of exciting for me when I see things working at the end of the lesson. And this is a kind of like organized way of doing things in the public cloud. So I really hope that you also enjoyed this section, and I'll see you in the next one. Thanks. Bye bye.
Hello and welcome back. So in this lesson, we are going to create auto-scaling groups for our production application, and we are going to hook it up to the target group so that it manages what instances are registered in that target group. So let's get started. So what is auto-scaling and why do we need auto-scaling? So basically, auto-scaling helps us in two key scenarios. First is it allows us to dynamically scale when there is a load that is coming up, or you could schedule, you could have a traffic pattern wherein you get certain amount of load in a specific day, specific time of the day, and then you could have your auto scaling group schedule so that you have instances scaled up during that amount of time, and then you can scale it back down when there is no load. So that's one scenario. And the second scenario is like you want to keep your costs low, because in the old the days before the cloud, what they used to do is like they used to over provision their instances, and then they used to purchase a lot of servers, and they used to configure it, and then even then you end up paying even though you're not using those servers, because there is the load is not there all the time. But in the cloud, you pay for only what you use. So auto scaling groups helps us to keep the costs low by dynamically scaling it. So let's get started. Okay, so let's see how this will work. So the auto scaling group functions basically on three main parameters, which is minimum size, desired capacity, and maximum size. So this minimum size tells us tells the auto scaling group that we need a minimum these amount of instances running all the time, and then you have maximum size, that is like this is the maximum amount of servers that you can scale up to. And then you have your desired capacity, which tells the auto scaling group at this particular moment how many instances I want it to be running. So basically your auto scaling group will run the instances greater than or equal to minimum size, and then less than or equal to maximum size based on the desired capacity. And so how would the auto scaling group know what server to boot up and how it where it needs to go and register it? So the launch configuration will tell the auto scaling group like what EC2 instance type it needs to use, what is the AMI that it needs to use, and what are the security groups that it needs to take, what are the storage options that you want to assign it to that instance. So basically you'll have the same parameters that you have when you're launching an instance, but instead you are going to save it as a launch configuration, and you'll assign this launch configuration to the auto scaling group, and auto scaling group will figure out a way to boot the new instance with the specific configuration. And the other thing that we use commonly is the scaling plans. This will tell the auto scaling group when and how to scale. For example, let's say you have a scaling plan that tells the auto scaling group to add more instances, and this happens when something triggers the scaling plan, like if there is a load that is coming into the load balancer, and it triggers a CloudWatch alarm, and the alarm will in turn trigger the scaling plans, and the auto scaling group will start adding new instances to the target group in order to handle that amount of load. So these are the type of use cases that we get out of the scaling plans. So let's get started with the creation of the auto scaling group. So to do that, we are going to go to the EC2 console, and here we are going to go to the auto scaling groups. So once you're here, you can hit create auto scaling group. So like discussed, we need a launch configuration for an auto scaling group. So we are going to create launch configuration first. So launch configuration is similar to the instance creation that we have done in the previous lessons. So we are going to choose the Amazon Linux AMI here, and we are going to choose the t2.micro, and we are going to give this a name. So I'm going to give it a name, my big company application LC for launch config, and then I generally give it the environment name and I give it the date when I'm creating this, so that I can keep track of the new launch configs versus the old launch configs. And I'm going to choose the instance role prod that we have created, and we want to enable CloudWatch detail monitoring because this is a production system. We want detail monitoring coming in so that we have more metrics when we are trying to figure out or investigate something that has happened. In the advanced details, we need our user data, which is the script that we have written, which will configure our application, copy it from the S3, all those things. So we pasted it here. Then we are going to add the storage. I think 8 gigs is more than enough. If you need more space, you could always add it here, or if you want new volumes, you could add it here. But make sure to check the delete on termination so that you don't have EBS volumes from the terminated instances to be lying around. And then we have to configure the security groups. So here we are going to select the security group that we want to assign here, which is our public security group, which is here. And then I'm going to go hit review, and here you can see that we have chosen the Amazon Linux AMI, and then we have our name here for the LC, and we have the role selected. We have the user data, which is encrypted here, and then we have some storage, which is 8 gigs, and we have our selected security group, and which is sending the traffic to the load balancer. I mean, like, which is accepting the traffic inbound from the load balancer. And we're going to hit create, and we can choose a new key pair, or you could have a separate key pair for each of the applications that you have in your production system. But for this lesson, I'm just going to choose the key pair that I already have. So okay, so the launch configuration is completed, and now we are going to create the auto scaling groups. So for the auto scaling group, we're taking a name. I would give it a same thing, my big company application ASG, which is for auto scaling group, and I'm going to give it a name prod. And I want to start with let's say 2 instances at least, because I want to put it in 2 availability zones. And we are going to choose a prod VPC, and the subnets that we put in here is actually the public secure subnet 1 and public subnet 2 in both the availability zones, because auto scaling group is launching the application servers, so that goes in the public subnets, and we want the auto scaling group to launch it in those 2 subnets. So we are going to configure it in the public subnet 1 and public subnet 2. And the next thing that we are going to do is like, okay, so there is the health check grace period. So what this does is, like, the health check grace period is it waits for this amount of time before it starts checking for the health of the application server. So in some cases what happens is, like, the application server takes more than it takes more amount of time to configure itself and then ready for the going into the load balancer. So we don't want our health check to be triggered prior to that, so that it results in an unhealthy and auto scaling group will try to take it out. So we want to wait for a certain amount of time. So that is what this number is going to tell us. So 300 seconds is more than enough for our server to go into service, so I'm just going to leave it at 300. And you can always have instances protected from scaling. That is, whenever some alarm happens and your auto scaling group scales in, that is like decreases the number of instances. If you want to protect these instances, you can protect it, but I don't want to put that now. I'll talk about the use cases in the next lessons. So I'm going to configure. So let's keep this scaling policies to the next lesson, because we want to understand how the auto scaling group works first, and then we'll try to come back to this and configure this properly when we have all the alarms and everything else is set up. So I'm just going to skip this part now. I'm going to go to the configuration of notifications. We're going to skip this part as well, because I'll talk about this once we have the SNS topic created, so that we could use this here and then we could use it for our notifications. So next thing is, like, I'm going to key in the tags, which is our name tag and my big company application ASG, and I'm going to give it as prod, and as usual I'll key in the as prod. Okay, so we have the auto scaling groups here, minimum and maximum size. I want to change this to be I don't see an option to put in the maximum size. Okay, I think we can put that once this is created. I'm just going to leave the scaling policies and notifications for the later lesson, and I'm going to hit create. So now what this is going to do is, like, now the auto scaling group is created, but we haven't told it where to keep the where to launch the instances and assign it to which target group or something like that. So now that this is created, we are going to go here and edit this, and here you have the target group section, and here you could select the target group that you have already created in the previous lessons, and you're going to tell that we need maximum of 4, and we want the health check type to be ELB health check. That is, like, now this is going to check the target group's health instead of the instance health. If you go to your instances itself, you have a separate health check that is assigned to this, and this is going to show it here. I mean, like, the status checks. If something goes bad here, then this would turn into unhealthy, but we don't want to check this, because this doesn't tell us if our application is healthy or not. It just tells us if the instance is healthy or not. But instead we want to use the application load balancer's health check, wherein this is going to tell us if our application is working fine or not. So let's go back here, and I'm going to choose the ELB health check here, and termination policy, we want to keep in the oldest instance. That is, like, whenever a new instance scales up, we want the old instance to go out when it scales down, rather than having the new instance go out. So I'll explain the use cases for this in the next lesson as well. So that's it for this part, and I'm gonna hit save. So now what this is going to do is this is going to boot up new instances, the 2 new instances, and if you see here, they have launched successfully. Let's see if they entered the target group or not. So if I go back here in the target group and hit refresh, I should see 2 new instances getting added to our target groups, and you can see that this auto scaling group launched the instances in both 1A and 1B, because we want our servers to be present in both availability zones. That's why we have minimum of 2 servers, so that it can launch in both the availability zones, and even if one zone goes away, then you have the second zone up and running. Now that we have our auto scaling group configured to these to put in the servers into the target groups, we can go ahead and terminate these application servers that we have created manually. Before that, I just want to check if they are all in healthy state. So I'm going to go to the application servers here. I'm going to search for these 2, and then I'm going to terminate those 2 servers. Select those 2 instance state terminate. Now I want to go back here, go to the load balancer and check if this is still working as expected or not. So I'm going to go to this, and yes, so I am getting back my response from my production application. Now we have auto scaling group configured so that we could add more amount of instances. We can decrease the number of instances that we want in our target group to handle our load. So that's it for this lesson, and in the next lesson what we are going to do is like we're going to create the scaling policies. We are going to create the alarms that are required for our load balancers, so that without your intervention, if there is some load that is coming in, the auto scaling group and the load balancer will figure out whether or not to scale up the new instances. So that's it for now. I'll see you there. Thanks. Hello and welcome back. So in the previous lesson we have created our auto scaling group, and in this lesson we are going to create SNS topics. We are going to create CloudWatch alarms and attach it to the target groups, and also we are going to create scaling policies for the auto scaling group. So let's get started. So first thing, go to your home page in AWS console and then search for SNS or simple notification service. So here you can create the topics, and you can assign these topics to the scale up or scale down events, and this will send notification to whoever subscribed to that topic. So we're going to create a new topic here, and I'm going to create one for scale up alarm, and you can just do scale up here and then create a topic. And we also want a alarm when we go scale down alarm, scale down. Also what we are going to do is we are going to create another topic which we'll use for let's say if there is something like service latency, service anomaly. So if there is any service anomaly, we'll try to trigger this SNS topic so that you can subscribe to any service anomaly like high latency or high CPU or anything like that. We'll use this as the trigger. So we're going to use service anomaly. And then I'm going to hit create topic. Okay, so now we have our SNS topics ready. So now I'm going to jump back to the EC2 section. And what we are going to do is go to the target groups, and before configuring target groups, I want to go and configure the scale up policies and scale down policies in the auto scaling groups. So here select this and go to the scaling policies. I'm going to add a new policy. I'm going to do create a simple scaling policy. Okay, so we're going to name this policy as scale up policy, and I'm going to create a new alarm, and the alarm is it is going to this is for scale up policy, and here we can choose the topic that we have created earlier. So we are doing a scale up alarm, and what we are doing is like whenever there is average CPU utilization across our instances is greater than or equal to, let's say, 65% for, let's say, 5 consecutive periods of 1 minute. That is like if your instances are having CPU, let's make it 70 so that it is like a little bit higher. So whenever there is 70% or more, 70% of CPU utilization or more for 5 minutes across the instances, then this is going to trigger an alarm, and that alarm is going to add one new instance, and it will try to handle that load. So what we are going to do is high CPU scale up alarm. So now we are creating this alarm, okay, and that got selected here. And what we are going to do is like add one instance, and then we are asking it to wait for 300 seconds for another scale up activity. So we don't want to be too aggressive as well, because once the instances, I mean like once a new instance gets added in, it needs some more time to reduce the load, and you don't want to like aggressively add more number of instances. So let's make this 500 actually, and then hit create. Okay, so we have now simple scaling high CPU scale up policy, and we're going to add another policy, which is what we're going to do is we'll have a scale down policy, and this is going to be the same thing, average CPU's utilization. And no, we're going to create a simple scaling policy actually, scale down policy, and we want to create a new alarm for scale down. We'll choose a scale down alarm from our topics. Average CPU utilization is less than or equal to 20%, that is if for at least 5 consecutive periods of 1 minute. So what this is doing is like let's say you scale up with a high CPU alarm or something like that, and once your load subsides and your application starts to get to normal, then you'll see that your CPU utilization will go down. At that point you want to scale down, and that's why we created this alarm. We are creating this alarm so that it is going to check for the low CPU thing, and if it is below than 20% for 5 consecutive periods of 1 minute, then it is going to take down one instance, which is going to be the oldest instance, as we have put in the oldest instance termination on the auto scaling group. So I'm going to name this as scale down alarm, and then I'm going to hit create. Okay, so that alarm has been created here. Actually we should have named it low CPU scale up alarm, scale down alarm. Okay, let's recreate that alarm. Here is less than or equal to 20% for 5 consecutive periods of 1 minute, low CPU scale, I want this to be lowercase, scale down alarm, scale down alarm. Okay, I'm gonna hit create, and then I'm gonna close, and low CPU scale down alarm is selected here, and we are going to remove one instances, and we are going to wait for 500 seconds before another scaling activity happens. So I'm gonna hit create. So now we have scale ups and scale down based on the CPU, and we are going to get a notification whenever a scale up activity happens here, whether it may be adding a new instance or anything like that. We'll have a whenever there is a high CPU, then we'll get a notification here. And the next thing that we're going to do is go to the notification center, and we are going to create a new notification. And what we are going to do is whenever there is launch, terminate, fail to launch, and fail to terminate, we are going to okay, we'll create another topic saying auto scaling activity notification. and we will add the subscribers later. And basically what we are saying is like whenever there is a scale up or scale down, or there is any scaling activity that is going on here, we want to choose a notification here. I don't think it's allowing me to create a topic without the recipients. So what I'll do is like I'll go back to the SNS console here, and I'll try to create there. Topics, and then I'm going to create a new topic which is going to be auto scaling activity underscore notification scale, and then I'm going to hit create topic. Okay, so now we have our auto scaling activity notification created. Then I'm going to go back here, I'm gonna hit cancel, just gonna hit refresh so that it gets updated with the new SNS topic here. I'm just gonna do a create notification, select the activity notification, and I'm going to choose everything and then hit save. So now what's happening is whenever there is any auto scaling activity that is happening, then this alarm gets triggered, and this will notify us whenever there is some activity going on. Okay, so the next thing that we are going to do is we are going to create some CloudWatch monitorings for our target groups. To do that, we'll go to the target groups, and here you'll go to the monitoring, and you can see that there are no alarms triggered as of now. So what we're going to do is we're going to create an alarm here. What we'll do is we'll send a notification to service anomaly, that is whenever there's something bad happening here. And what we are going to do is whenever there is the average of average latency is greater than or equal to, let's say you have, so you'll get to know the exact number here once you have your service running, and you kind of know like the trends of the average latency, then you can trigger it. Usually what I would feel is like all the services should return like under 750 milliseconds. So that's what I believe is the high latency. So this is going to be 0.750 seconds, and for at least 5 consecutive periods of 1 minute, then I'm going to say high latency alarm, and this is, you can give application name here so that you know which application is having high latency. And then you're just going to do a create alarm, and you're also going to we are also going to create a low latency alarm, wherein whenever there is a latency, we always need like high latency and low latency, or high CPU and low CPU, so that we get to know whenever the service went back to normal after a anomaly happened. So what we are going to do is like we're going to select the service anomaly again here, and we are going to go by average of the average latency is less than or equal to 0.3 seconds. This is considered as normal for me. Then I'm going to go for like 5 consecutive periods of 1 minute. Then I'm gonna say application low latency alarm. So this is what this is what we are going to do here, and we're gonna hit create alarm. So now that we have created these alarms, now what we can do is like we can hook this up to the auto scaling groups back again, so that whenever there is high latency you could also scale up, because sometimes what happens is even though your CPU is low, your latency might go up, and you might need more instances to handle that kind of load. So in that scenarios, you need to scale up. So what we are going to do is like we'll view this in the CloudWatch alarm itself, CloudWatch page itself. You can do that by clicking it here. Then you go to this page, and then you can see that there is like application high latency and application low latency. So here what you can do is you can kind of go here and then go to actions and go to modify, and you can also add a new action here, which is the auto scaling action that we want to do. So what you're doing is, whenever this alarm state is an alarm, that is whenever this goes off from the resource type auto scaling group, we want to use this auto scaling group, and we want to do a scale up policy, which is adding one instance, and we're just going to save it here. Also, we need a notification whenever the alarm state goes to OK. We'll send the notification to anomaly. So what is happening here is, like, whenever there is an alarm, you send the notification to service anomaly, and then whenever there is a alarm, you're also adding a new instance using scale up policy here, and then whenever the state goes to OK, then you're sending a notification saying that your service is back to normal, and you can hit changes, save. So now this is done, and you're going to configure the low latency alarm now. And here what you can do is like go to actions and modify, and you can do the same thing here. We want to add a notification whenever there is status in alarm. Actually, we don't need an alarm when the low latency is there, because we don't care when there is low latency. We only care when there is high latency, and we have configured an alarm when it goes to OK state. We are going to get a notification anyway. So but we need a auto scaling action wherein when this state is an alarm, that is when it is low CPU low latency, then what we are going to do is we are going to do an auto scaling, and we're going to select this auto scaling group, and we are going to scale down. That is, we're going to remove one instance so that when we we don't need more instances, because the application is performing very well under the required constraints here. So I'm gonna hit save changes here. Now you can go back to the, now we are done configuring all the alarms. Now you can go back to the EC2 section, and here in the target groups, you should be able to see in the monitoring section that your alarms have been configured and you have everything set up here properly. So now that this part is done, what you can do is like you can go to the SNS, and you could subscribe to these topics, and then you would receive notifications whenever some activity happens. Like we could test a scale up alarm by going here. No, actually we'll just do auto scaling activity, and I'll create a subscription. I want to send an email to, let's say, my email address, and then create subscription. I'll have to go back to my email and then confirm the subscription so that I'll start receiving the notifications. So what we can do is let me open up my email. Okay, so now I have my email open here. So I got a email from AWS notification to confirm the subscription. So I'm gonna hit confirm, and now that my subscription is confirmed, what I can do is like go back to the auto scaling group, and I'm going to add a new instance, and let's see if I get a notification once we get a scale up. So I'm going to edit here, and I'm going to increase the desired capacity by 3. Then I'm going to hit save. let's see if I get a notification. I'm gonna pause this for a second. Okay, so now that the instance is added here, you can see in the activity that it launched a new instance. If I see here, I got a new instance here, and I'm going to go to my email, and yeah, I got an email saying that there is a auto scaling event happened, and what happened here, who, like, a user requested update to auto scaling group constraints, and he changed to this so and so number, and these are the details, and this is where it launched a new instance, and all those kind of information, which is really useful when you're away from a system and want to check what happened, and get to know what happened, what's happening in your production environment. So this is how you configure your alarms, and you configure your notifications. This is really helpful when you want to monitor your AWS environment even though you're not logged into the system. So that's it for this lesson, guys. I will see you in the next one. Thanks.
So this will be our end of auto scaling group setup section, and let's do a quick recap on what we have done in this section. So we started off by looking at the auto scaling group concepts and what are the different options that we have when we are setting up the auto scaling groups. And then we created our first launch configuration by supplying different parameters that we want our application servers to have. And then we created the auto scaling group by using the launch configuration. And we have created the scaling policies, the CloudWatch alarms, and we have created the SNS topics, and we have used all these together, and we have hooked it up to the load balancer and to auto scaling group, and we have tested the auto scaling group by booting up new instances, and also we have tested our scaling policies and SNS topics and alarms by checking the notifications in our email. So I think we have covered a lot of information here, and I really hope that you enjoyed this section, and I'll see you in the next one. Thanks. Bye bye. Hello and welcome back. So in this lesson we are going to talk about the database servers in our private subnets. So let me open up my architecture diagram here. So far we have completed the application server setup, we've completed the DMZ setup, we've got the auto scaling setup, and the next step that we are going to do is like setting up the database servers. As we don't have an application that is actually using a database, I'm just going to show you how to configure the security groups, and launching of the database server is exactly same as that we have done for the application server, except that it doesn't need any load balancer or it doesn't need any auto scaling, because database servers usually don't scale. So let's get started. So what I'm gonna do is I'm gonna go back to my EC2 here, and what I'm going to do is I'm going to go to the security groups first, because I want to configure the security group which allows the traffic to this particular database in private subnet. So I'm gonna go create a security group. I'm gonna call it private security group for the database servers. So here what we'll do is like we'll put in the incoming port range, port numbers that we need to access the database. So for example, let's if you are configuring a MySQL server, then what you would need is like you would need an inbound rule that would allow port 3306, and you want this to be accessible only from your public subnets, because you don't want your internet to be able to access this particular database on that port number, because this is like behind the layers of firewall. We want this to be only accessible from the application servers. So here I am going to select trying to get the autofill working for me. Looks like it doesn't like it. I'm gonna copy it from here. I'm just gonna open it here, and I'm going to copy the public security group from here,
and I'm going to paste that in here. And this is for the access to application servers on. And if you have some internal applications that are running in this port number, running on the private subnets, then you could also have HTTP coming from your same private public security groups, as well as access to port for application servers. And in some case, if you want to if you want your load balancer, if you want to hook up a load balancer to this, I would not do that here, because we don't want to give permissions that are not required here. So I think this should be good enough for the database server to be accessed from the application servers. So all we gotta do now is like create our database server. This can be a database server hosted on a EC2 instance, or this can be even a RDS server. Like you could go to the RDS section here, and then you can create your own database server like MySQL, Aurora, or any other RDS that Amazon offers you. Okay, so now that we are in the RDS section, what we need to do is go to the subnet groups, and we need to create a new subnet group so that the RDS can choose that subnet group to host the RDS instance in. So I'm gonna name this as private DB subnet group. Subnet group for RDS. I'm gonna choose my prod VPC here, and then my preference is going to be 1A, and then we are going to choose the private subnet here. So let's look up what our private subnets are. One of them is this guy, 556. Let me choose the 556 one here, and we are going to choose 1B. Inside 1B we have private subnet 2, which is 4CA, and I'm going to choose the 4CA one here and add it to this. So now when the RDS instance gets created, we select this subnet group, then it's going to be launched in these two subnets. So we're just going to hit create. Now we will go to the instances here, and we'll launch a new DB instance. We can choose Amazon Aurora or MySQL. There's no real difference for this demo. We can choose a production Amazon Aurora because it's similar to MySQL. We'll choose the smallest one just to see how this gets created. We don't need multi-AC, or we could just select here. We could just give some name here, put password, and here's the important thing. You're gonna choose the prod VPC here, and then it automatically selects your new private subnet group that you have created, and you can choose if you want to expose this publicly, or you want to put this internally. So by with our architecture, we prefer to keep it inside internally accessible, so that no one outside this VPC can ever access our DB. It's really not required for us to expose our DB in this scenario. So we're going to choose no here, and then we could choose our preference. That's up to you where you want to create your DB instance, and then you can select the existing security group that we have created just a few minutes back. That's a private SG, and you can take this off the default SG, and you can give the DB cluster name if you want, and select all the defaults or any other configurations that you want to make and launch the DB instance. Once you launch this DB instance, then all the application servers should be able to access that specific DB instance on the port 3306, which is the default port on which the MySQL gets accessed. So that's it for the database configuration part. As we don't have a running application that has the DB connectivity, it is really hard to simulate that kind of demo in this lecture. But if you have any questions about this, you can comment in the comment section, and then I'll get back to you on with the reply of like what you need to do in your scenario. So that's it for this lesson. Thanks. Bye bye. Hello and welcome back. So in the previous lesson, we have configured our application load balancers, but we haven't configured it for the HTTPS. So in this lesson, what we are going to do is create a ACM cert, which is like Amazon issued SSL certificate, and then we are going to assign it to our load balancer by creating a listener for HTTPS and forwarding that to our target group that we have created earlier. So let's get started. So first you need to go to the certificate manager in your AWS console, and then you need to get started here. You can specify the domain name. First you need to have a domain name. I believe every company has a domain name, so I'm just gonna request for star dot this is the domain name that I own, so I'm just putting star.cyclonathan.com, and then I'm hitting next here, and then I'm gonna choose email validation. So what AWS does is like it creates it checks for the register for that domain and sends an email to him saying that someone is trying to generate a certificate on your behalf, and do you approve of it? And once the registrar approves that, your certificate is ready to use. So I'm gonna choose the email validation here, and then I'm gonna hit preview, and then I'm going to request this. So now I should be receiving an email to my registered email address of my domain. So I'm gonna go to my email and check. Okay, so now I got an email saying that someone is requesting for this domain, and if I want to approve, then I just need to click this link here, and then I just need to hit I approve. So now our certificate is validated here, and I can go back here and hit refresh, then it should be issued state. Okay, so now we have a cert. The next thing that we are going to do is go back to our application load balancer. So you'll go back to the EC2 part, you'll go to the load balancers, load balancers, and then you're going to select this, and you'll go to the listeners. We want to add a new listener, and we want to listen on HTTPS, right? So you just click add listener, you would choose HTTPS, and we're still going to use the same target group. It doesn't matter if your target group is hosted on port 80 or 443, as long as you have your load balancer port pointing to receiving traffic on 443, you can always redirect your traffic back to port 80 from load balancer to your application server. So I'm gonna choose the same target group, and we are going to choose a certificate from the ACM, and which is going to be star.cyclonathan.com from here, and then I'm just gonna hit create. Okay, so this is saying that our security group doesn't allow that port 443 traffic incoming. That we're gonna fix it right away. So what we're gonna go do is go to the external ELB security group, and in the inbound traffic, what we are going to do is add another rule, which is HTTPS, and we're gonna say that we can receive traffic from everywhere for this, and hit save. Now if I go back here and go to my listeners, I should have my 443 listener listed here, and all the requests are being diverted to my this target group. So let's test if we can get the HTTPS working here. If I go to this is the HTTP, and if I put HTTPS, then it complains of being not secure because you're not using the same DNS here. But once we configure our Route 53 to point to that specific domain, then this would start working. So if I hit proceed, even though it is HTTPS, it is not secure because it is not validating the certificate that we issued. So that's it for this lecture. In the next lecture, we'll configure our DNS, which is the Route 53 part, and that is going to point our application to a specific domain name. So I'll see you there. Thanks. Bye bye. Hello and welcome back. So in this lesson, we are going to configure our Route 53 part for our production infrastructure. So the one thing that you require to complete this lesson is a registered domain name. It can be from the Route 53 itself, or you could purchase any domain from DNS providers like GoDaddy or any other providers. So let's get started. You need to go to the Route 53 from AWS console, and you need to go to the hosted zones, and you need to create a hosted zone. I've already created my hosted zone, which is for saikiranratan.com. That's the domain name that I'm going to use now. So you just need to key in your domain name here, and then you need to choose the public hosted zone and then hit create. So once you hit create, you will be provided with default records from the Route 53 itself. So you're interested in the NS records. So the next thing that you're going to do is log into your DNS provider. For in my case, it is godaddy.com. So I'll log in here, and then I'm just gonna go to manage my DNS. So here, as I've already connected it to my account, you might not observe here. So there are some default records that are pre-assigned to the name servers of the GoDaddy itself. But what we're going to do is, like, we're going to change it to custom name servers, and then we're going to put in our name server entries that we got from the AWS Route 53 itself. If you see here, these are the entries that I got from the AWS Route 53. So once we enter it here, it takes like some time to propagate, and once it is propagated, then all your you can just create your subdomains and manage your DNS directly from Route 53, and you don't need to go to GoDaddy to manage your DNS anymore. So once we do that, we come back here, we just create a new record set, and we are going to point it to our ELB there. So for this application, let's call it my prod application .saikiranratan.com, and I'm going to choose this as a IPv4 address, and I'm going to choose it as an alias, and we are going to point it to our ELB, which is my big company ALB, and I'm going to choose the simple routing policy. You have different options like weighted latency or failover, or there are different use cases for different things, but in our case we are going to choose the simple routing policy, and we are going to hit create. So now what happens is, in a few minutes we should be able to browse our production application just by entering myprodapplication.com. So this is a new DNS entry. This is going to take a few minutes to propagate for the DNS records. I'm gonna pause this and then come back once this is ready. Okay, so after a few minutes and a DNS flush, I can now resolve this domain name and I'm able to get my production server configured. And also we can check this using HTTPS, as we have created a HTTPS cert and assigned it to our load balancer. So now we have our production application running on HTTP and HTTPS, and we have a DNS entry pointing to that application. So basically this is it for the DNS part, and I will see you in the next one. Thanks. Bye-bye.
Hello and welcome back. So in this section of the course, we are going to learn about Terraform and we are going to implement this in our production infrastructure. So before getting started, let's learn something about Terraform. So what is Terraform? Basically, it is a open source tool developed by HashiCorp. What this does is it helps you to store your infrastructure as code, meaning you can have your entire infrastructure in the form of a code, and it makes it easy for you to save this code in a subversion or a GitHub, and which enables you to share your infrastructure with among your team members, and you could also modify your infrastructure or recreate your infrastructure. So let me tell you the use cases behind this. So let's say you have an infrastructure that is created by Terraform and you have that configuration file with you. Now someone in your team goes in to the let's say we're using AWS in the scenario. He goes in and changes something in the in your configuration of your production infrastructure, but he forgot what he changed. So to get the actual desired state back, you can go back and get your Terraform configuration that you have saved in your versioning. You could just run that script again and get back your infrastructure to the desired state. So this helps you to keep you a consistent environment. And also the other use cases that you might have is, let's say you you want to spin up a new environment with exactly the same configuration that you have currently in your production network. Let's say you want to create a pre-prod or a QA network. So in those scenarios, what you want to do is you just need to change a few variables which define like which network it's going to get created, and then all you got to do is like run this Terraform and you have your new environment with exactly the same configuration that you have in your production infrastructure or any other infrastructure that you are recreating. So it's very simple to use, it's very manageable, and it is also a widely used tool in the current industry. So that's the reason we want to learn Terraform, and we want to save the infrastructure that we have created in our previous lessons using Terraform, and we are going to see each and every step of like how do you write the configuration, how do you explore the documentation to get your desired resources to configure, and we are going to see how we basically use this Terraform in our infrastructure. So let me also tell you the steps that are involved in getting your Terraform to run. Is first thing, you need to write a configuration file, which is going to be a .tf file, which uses a HCL language, which is HashiCorp configuration language, and this is a very simple language and it is easy to use. It is mostly English and it is kind of a declarative language. So when you read the configuration file, it is straightforward, saying that okay, I need a load balancer, I need a name to it, this is the configuration that I'm going to give, and that's it. You just run that plan. So once you have the configuration file ready, the next thing that you're gonna need is to do is like plan the infrastructure. That is, you're going to run a command saying Terraform plan, and then what it's going to do is like it's going to check against the current infrastructure, and it's going to see what are all the resources that you need to create in order to get to your desired state of configuration. And then it's going to list out to you saying that, okay, so these are the resources that we are going to create. So once you have a plan in place, the next thing you're going to do is like Terraform apply. So once you do that, what it's going to do is like it's going to apply the configuration to your the cloud infrastructure, and then it's going to create all the resources that you want in order to get to the desired state. So these are the three simple steps that we need to do to create your infrastructure using Terraform. And when you modify your configuration, it's again the same steps. You're going to modify your configuration file, you save it, and then Terraform has two files that are generated when you first run the Terraform script. What it saves is like it saves the information and the data, like what's the IDs that has been created for the resources, something like that. And then whenever you run the second time or the third time, what it's going to do is like it's going to synchronize with the current infrastructure that is running in your cloud, and it's going to compare with what's new resources that it's going to create, or what's getting modified in the current resources, and it's going to apply those changes in order to get to your desired state. So enough of Terraform. Now that you know what Terraform is used for and how important it is to have a Terraform script configured for your production infrastructure, let's get started. That's it for this lesson. I'll see you in the next one. Thanks. Bye-bye. Hello and welcome back. So now that we know what Terraform does, let's go ahead and install it in our computer. So all you gotta do is like go to this website terraform.io. I have it open, so I'm gonna pull this here, and you're going to download whatever the latest version is. So I'm just going to choose 0.11.1, and then I'm going to choose my operating system. You can choose any other operating system, but I'm going to use Windows, and it is really simple to install it on any of the operating system, as all you got to do is like download the binaries and point your path to it. So that's what I'm going to do in the Windows. So I hit download, and I'm going to create a new folder, and I'm going to download it here. So once it is downloaded, what I gotta do is like extract the files in this, and I'm going to find a executable here. So what I'm gonna do is like copy this executable from here and put it in my C program files so that I can better track where my programs are installed. So I'm gonna do Terraforms here, and I'm gonna paste it here. So now for your Terraform to get recognized in your command line interface, all you got to do is like add this to your path variable in your environment variables. So I'm gonna do edit environment variables, and I'm going to add it to my path. So here's my path, and I'm going to create a new one, and I'm going to add a Terraform here. Oh, I added it twice. So I can just take this off, and then I can just hit OK. So now that you have Terraform downloaded, put it in a specific location that you want, and then we have added this to our environment variables path. And next thing that I'm gonna do is open up PowerShell, and I'm going to check if I can run this command here and whether it's getting recognized. So like you can see, Terraform is getting recognized because it's in our path, and we have a bunch of different options that we can choose from here. So that's it for this lesson. In the next lesson, we're going to see how we start with our configuration and how we plan and run our infrastructure. So I'll see you there. Bye-bye. Hello and welcome back. So now that we have our Terraform installed and ready, the next thing that we're going to do is set up our command line interface for AWS. And to do that, we need to create a IAM user for Terraform, and I'm going to save the credentials in our AWS CLI, which we are going to just install in a bit.
and I'm going to save it as a profile so that I can give it as an input to the configuration file, and the Terraform is going to use that user with that permissions that it got, and it's going to use it to create the infrastructure. So let's get started. To do this, first we are going to go to our AWS console here, and then what we're going to do is we are going to go to the IAM section here, and I'm going to create a user for the Terraform so that I can control what permissions are given to this. So I'm going to go here and add a user here saying Terraform user, and I'm just going to give it a programmatic access because this is meant to be just for the running the script, and I don't want this getting any console access, whatever. So once I hit programmatic access here, I'm gonna hit next, give permissions, and I'm going to just give the administrator access for now, but you can always fine-tune what you want to give to this Terraform user. So I'm just going to create user, and I'm going to download this .csv into my softwares folder. Okay, so now that we have our credentials downloaded, basically it is access key and secret access key that we are going to set it up in our CLI. So the next thing that we have to do is download the AWS CLI. So for that, you can just Google download AWS CLI for Windows, and you can go to the first link here, and then it's going to show you different options. We just have to install it for Windows. So I'm gonna choose Windows here, and I want to download a MSI for 64-bit, and it's a basic installer, so you can just run this. I have it already installed, so it doesn't allow me to. I think it does allow me to install, so I can just hit next, and then I just have to hit install here. I have it already installed, so I'm not going to install it again. So I'm just gonna cancel it from here. And the next thing that we have to do is configure this AWS CLI with the credentials that we have just created. So to do that, I'm just going to open up PowerShell. You can always use the regular command prompt, but I'm much comfortable with PowerShell, so I'm just going to use this. So here what we're going to do is we're going to do AWS configure and -- profile, and we're going to give a profile name, so which is Terraform -user. This can be anything that you can create here. This is just for your reference, and then if I hit enter, it's going to ask for my access ID. So I'm just going to open up my credentials here, and then I'm going to copy this part from here. This is my access key ID, so I copied this. I can paste it here. Next thing that it's going to ask me is the secret access key. So I'm going to copy my secret access key from here and then put it here. And the default region that I'm going to choose is EU West 1, because that's where we are setting up our production infrastructure. So, and I can just leave the default option for format, and that's it. So now you have your Terraform user configured in your AWS CLI. So that's it for this lesson, and in the next lesson we're going to see how we create the configuration file for our Terraform. Thanks. See you there. Bye-bye. Hello and welcome back. So now that we have our AWS CLI and Terraform installed and ready, we're going to start with our configuration. So to do that, what you need to first do is you need to choose a folder where you're going to create your Terraform. So I'm going to use this folder here, and I'm just going to create a new folder inside this saying Terraform, and inside this I'm just going to create a new file which is going to be a .tf file, which I'll name it as production application.tf. Yes, I want to change the format here, and inside this file what we're going to do is we're going to specify a provider, and we are going to do a Terraform init on that so that it pulls the required plugins. So first let's go to the Terraform documentation and see how to do that. So first we go to the terraform.io website and go to the docs section. So inside this docs section, you're going to choose a provider. So as we are working in AWS, we are going to choose here. If you're going to use some other providers, you can always check out like all the providers that it supports. There's a wide range of providers that you can configure with using Terraform. Here we're using AWS, so I'm gonna choose AWS. So there are a bunch of different ways how you can configure your provider in your Terraform scripts. I don't like to expose my access key and secret access key in my configuration file because people tend to steal your information if it's there out in open. I mean, I don't want to check in my credentials in a version control or share it across the team, because I like it keeping it in my computer itself, and then I'm just gonna give the profile name here so that whoever is running that script, they should have their own profile set here before they run, so that they're going to use their level of access instead of a global level of access. So I'm going to choose this method of using the AWS provider. So I'm just gonna copy this part, and this is going to be the first block of code that I'm going to put in my configuration file. So I'm gonna go to this folder and I'm going to open up using I'd like to use the Visual Studio Code, so I'm just gonna open up a new Visual Studio Code. You can use your choice of editor, but I'm gonna choose Visual Studio Code. I'm putting my folder there and opening it. So basically this is a blank folder here, and what we're gonna do is paste this block of code here into this section, and I'm going to change my region because we are using EU West 1, and I'm not using a shared credential file. Instead, we have it already configured in our AWS CLI that we're going to use Terraform-user. Okay, so now that we have created the configuration file and we have supplied what provider we're going to use and which region we are configuring and what profile we're going to use here. So I hit save, and then I'm going to open up my PowerShell. I'm just going to clear this out, navigate into this folder, and here we're going to run a Terraform init. Now let's see what this does. So basically what it is doing is like it's checking our configuration file, and it's checking what provider this is going to use, and it's going to download that required provider's plugins, and it's going to configure and create a folder inside that with the required configuration. So if you see here, then you have the plugins downloaded for your computer and whatever the dependencies that it requires. So now that we have configuration file here ready, and it is initialized, we can start adding our resources into this configuration file. So I'll do that in the next one. Thanks. Bye bye. Hello and welcome back. So in the previous lesson, we have initialized our configuration file, and we have downloaded the required plugins using Terraform init. And in this section, we are going to create some of the resources. So before doing that, let's check our architecture diagram and see the requirements that we need, the resources that we need to spin up in order to get to our desired configuration. So let's look at the diagram now.
So here, what we're going to do is like first we need a load balancer. By the way, we are not going to recreate our entire architecture, but we are going to create the resources that are required for our application itself. So the requirements are the load balancers and the application servers configuration, the autoscaling groups. So these are the three things that we are going to create. So first thing we're going to do is like we're going to create the load balancer. So to do that, let me pull back my configuration file here, and we're going to go back to our documentation for the Terraform, and we're going to create the load balancer. So first thing you need to do is search for your load balancer. So it should be called AWS load balancer, and let me see. So basically this is an application load balancer, so it should be called ALB here. So we're going to choose the, so under EC2 resources you can see that we have AWS ALB. So I'm going to open this up here, and you can always look at an example here and then you can work on it to get to your required configuration. So I'm just going to copy these this example block here, and then I'm going to modify it according to my needs. So I have this copied here. So what this is basically doing here is like it's saying I need a resource of AWS load balancer, and I need to create a I need to give it a name so that I can reference it locally within this configuration file, and I'm gonna need the name of the load balancer itself. I want to know if it's an internal load balancer or an external one. I need to specify the security groups here. I need to specify the subnets like we did everything through the console. So let's put in our configuration here that we want to do. So I'm gonna say here prod app dash ALB, and I'm just gonna give this name of our load balancer is production. No, I'm just gonna give my big company application dash ALB dash prod. So I'm just gonna give Terraform so that we can differentiate between different between the one that we have created through console and Terraform. We need it external, so that's going to be internal equal to false, and we need the security groups that we have created here. So what I'm gonna do is go to our AWS console and get our security group IDs that where we want to put in. So basically you can also create your security groups using Terraform. For this lesson I'm not going to do that. I'm just going to use the ones that we have created through the console. So I'm gonna go to the security groups here under network and security, and we are going to choose the ID for the DMZ subnet. As you can see, you need the DMZ subnet for your load balancer. So I'm gonna choose the DMZ subnet. So we have here DMZ subnet, which is our external ALB security group. This is meant for our DMZs. So I'm gonna copy this here, and I'm gonna paste it in here. So what this is going to do is like it's hard coding our security group into the configuration file, which I don't like doing that, because if I'm gonna recreate my environment, I don't want to go in and change each and every place where this security group is getting used. So instead I'm gonna use a variable. So now let's go back to our Terraform documentation, and let's see how we can configure the variables. So what you could just do is like I just don't want to close that page, so I'm gonna go here
and I'm gonna search for Terraform variables. Okay, so now here we can see the different ways in which the variables can be declared here. We're gonna choose the first example wherein we have the key, we have the type that you can specify, whether it's a string or a map or any other format that Terraform supports, and the default value that we're going to use for this. So I'm going to choose this type of declaration for variables, and what I'm gonna do here is, like, on the top, I'm just going to paste this here, and I'm going to say external ELB security group ID, because it can be subnets as well. So I'm not going to put anything here. I'm just going to leave this out so that Terraform automatically detects what type of an ID variable that we are configuring here. So I'm gonna give this a value of the security ID that we get from the AWS console here. So this is our security group ID. I'm going to paste it here. There's some extra space. So once we have that here, the next thing that we need is the subnets where we need to host our load balancer. So for that, I'm just going to create another variable here, and I'm going to say DMZ subnet IDs. So again, I'm going to go back to our EC2 console here, and I'm going to go to my VPC section to find out the IDs that I need for the load balancer here. Those are going to be the DMZ subnets. So I go to my subnet section and copy the subnet IDs from here. So the first subnet is this ID, and I'm going to use an array here instead of a single string there. So the array of strings is declared in this way, and oops, and here I need to put my second DMZ subnet ID. It's going to be this. Okay, so now I have my DMZ subnet IDs here. Okay, so I have my two variables here, so I'm going to use my variables here instead of the hard-coded value there. So inside an array, this is how you use your variables. So you have dollar open curly brace, and then you're going to say var dot what are the variable name, so external ELB security group ID, and here I need array of subnets, so I just can get rid of this array from here, and I can just say inside quotes, I can say that I need the DMZ var dot DMZ subnet IDs. And okay, so the next thing that we're going to do is, like, oh, okay, before doing that, I see a typo here. I need to add a quotes around this so that it doesn't throw me an error. Also, I think this name is too big, so I'm going to change this to app dot dash tf instead of big name, because I think AWS restricts the name to be it cannot be longer than 32 characters, I guess. So we're going to shorten the name here, and the next thing is we definitely need the enable deletion protection, because this prevents us from accidentally clicking a delete button in our AWS console, and this is going to prevent you from that. So I just need that to be turned on. And here we can also get the access logs out of the ALB, that is all the metrics that you get from the console. You can save it in your S3, and you can use some parser like Sumo Logic or any other logging system that you can parse these logs and get some useful info out of it. For this lesson, we're not going to use it, so I'm just going to remove this block of code from here. Okay, so we definitely need the tags, and as this is for our production application, I'm just tagging it as the production here. Okay, so now our load balancer is ready. The other things that we need for the load balancer are the target groups and the load balancer listener. The other things that we need for the load balancer are the target groups and the load balancer listeners. So let's go back to our Terraform documentation and let's see the other requirements. So we're going to go back to the EC2 section, scroll all the way down, and here under this we need the AWS ALB target group. So I'm gonna click this one, and I'm going to go here and use the example block from here. You can always check out the argument reference here and then add in the extra parameters that if you want to add in, because we are going to use a lot of default values, so I'm not going to put in a lot of resources information here. But if you want to customize stuff, you can always check out the reference here to get the required configuration. So I'm just gonna copy this part and I'm going to paste it in my configuration. We just need one target group, as we've seen that we had one target group and we had multiple listeners pointing to the same target group. So I'm just going to use this target group as my app dash tf dash tg dash prod, and I'm going to copy paste the name from here. We want it to be on port 80. We need this on the HTTP protocol, and one thing we need is here we need the VPC ID. So I'm just going to create another variable here called VPC ID, and I'm going to copy it from our AWS console. So if I go back here, under VPC prod VPC, we have the VPC ID. So I'm just going to copy it from here and put it in my configuration file here. So now here I'm just going to change my VPC ID as like this, var.vpc ID. Okay, so we've got the VPC ID, we got the protocol name and stuff. The next thing that we're going to do is go back to our documentation and see if we need anything else. Okay, we got the name, which is important. We got the ports, we got the protocol, we got the VPC ID. Deregistration delay, I think I'm good with the 300-second default, so I'm just gonna leave it there. I don't need any stickiness. Okay, I need the health check, and we're going to use the default path, which is our / as the health check. So to check how it is configured, if I just click this, I'm gonna see something here. Okay, so the health check block is defined as health_check. So to define a block, all you gotta do is like you put in the block that you want here, open curly brace and close curly brace. Inside this, you're going to use it as a key value pair. So you need the interval, which is going to be something like this, interval, and you're going to give it a number of I'm just gonna give it a number of 30, and I'm gonna put it under quotes 30, and I am going to give it a path of the default path. And we have the okay, let's go back to our console and see what we have configured so that it is easy to recreate that way. I'm gonna go to the EC2 section here and go to my target groups and go to my targets. Oh no, go to my health check, and we can see we have the HTTP protocol. So we need the protocol here, protocol, and we need to give it a HTTP protocol, and we have the port, which is, let's see how we can configure the port here. So basically this defaults to traffic port, so I don't need to specify a port here as we have the default, which is the traffic port. We need to give it a healthy threshold, unhealthy threshold, timeout, interval, and success codes. So let's go back to the documentation and open up the file here. Okay, so we need the healthy underscore threshold, and we need the healthy threshold to be this can be anything. I'm just gonna give it 2, and we need unhealthy the threshold. We're going to give this as 5, and we need the timeout, which should be less than the interval, so I'm just gonna give it like 28. And so the next thing that we need to do is we want the success codes. So let's see how we can configure the success code here. Okay, codes to use checking for healthful response. Okay, yeah, so this is what we need to do. So we need to get the matcher, so we need to put the matcher as matcher equal to we need it to be 200 because we are expecting a 200 response back. Okay, so I think that's it for the target group. The next thing that we need is the load balancer listener, so that we have a listener for HTTP and HTTPS, and those listeners are going to forward our requests to the target groups here. So let's see how to configure those. So to do that, I'm gonna go back to my documentation here, and if I scroll back all the way to EC2 resources, I can check for AWS ALB listener. Okay, so like you can see, for this load balancer listener, you need to have a target group and you need to have a load balancer. Okay, we have already configured those, so I'm gonna copy this section here and we're going to modify it according to our needs. So here first thing is I'm gonna give this a name. It's going to be app HTTPS HTTP listener. And okay, so the load balancer ARN. So what this is doing is, like, it's asking us to which load balancer we need to configure this to. So we want it to be configured to our load balancer here, so I'm gonna copy the name from here and put it here. So it is saying in load balancers use this load balancers ARN, and we are configuring it for HTTP, so I'm gonna choose HTTP here. Oh no, I'm gonna choose the AT port and I'm gonna choose HTTPS, HTTP instead of HTTPS. For HTTPS we don't need this configuration, so before this I'm gonna make a copy so that I can reuse this for HTTPS. For HTTP we don't need these two here, and the default action is we're going to send it to our HTTP target group. So I'm gonna copy the name of the target group and put it here so that this automatically gets the ARN. I'm gonna forward those requests. You can always add more rules here so that you can have different paths getting forwarded to different target groups. So okay, so next thing we need to do is configure the HTTPS one here. So I'm going to change the name to HTTPS. I'm still going to use the same load balancer, and the port is going to be 443, and this is going to be HTTPS. We are going to use the SSL policy, the default one, or we can match it to the one that we have created here. So if I go back to my load balancer listeners, I can check the security policy. So we are using this one, so I can copy this part here and paste it here. Okay, the certificate ARN is the one that you've created in the certificate manager, which is your domain's SSL cert. I'm gonna go here, choose my SSL cert, and copy the ARN, and I'm going to paste it here. Okay, so the default action is we need to forward it to our same HTTP target group. So I'm gonna copy the name here and put it here. So basically we are having two different load balancers. Oops, I copied the wrong one, so I'm gonna copy the target group's name here, and I'm going to put it here, and I'm gonna forward it this. So so far what we have is we have the load balancer, we have the listeners, we have the target group, and we have two different listeners which are listening on HTTP and HTTPS, and both are forwarding the requests back to the same target group. And let's try to run this Terraform and see how this is going to create our infrastructure. Okay, for that I'm going to open up my PowerShell. I'm gonna stay in the same folder where we have this configuration file, and I'm going to run this command terraform plan, and let's see what this does. So basically it goes and checks with your cloud, saying what all the resources that it needs to create, and it tells us the plan for that. Okay, so it's throwing a couple of errors here. It's saying unknown variable referenced here, and known resources front end. Oh, we might have missed something here. Let's see what line this is. Referenced defined block variable VPC ID. We have VPC ID here. Let's see where it would. Oh, that was all uppercase, so it couldn't recognize it there. Okay, so the next thing that we have problem here is in the HTTPS listener. HTTPS listener. I think we didn't save it. So this is complaining about front end. Do we have anything called front end? Okay, so I think I might have not saved it. Okay, now that we have everything saved, let's try to run this again. Okay. Oh, I made a typo here in threshold. OLD. Okay. Oh my god, I'm making so many typos. DHY unhealthy threshold. Okay, so now finally this ran, and we have the plan saying that it's going to create a load balancer first, it's going to create the listeners, it's going to create the target group, and it's saying that we are going to add 4 resources. There is nothing to change and there is nothing to destroy. So to create this, all we got to do is like run this command terraform apply. Oops, again I made it error, terraform apply. Okay, so now this is going to ask us for a confirmation whether or not we want to run this. So we can double check here. We are having a load balancer, listeners, and the target group. So if you're okay with this, just type yes here and press enter. Now this is going to create the resources, and we can go back to our console and check if these resources are created or not. So let's jump back to the console. Let us wait until this gets finished. It's just going to take a few minutes to just create the resources it wants. I'm gonna pause and come back once it's done. Okay, so this completed after like a few minutes. It really took some like around 2.5 minutes to create the load balancer. But once this is done, you get a successful message saying that 4 resources were created. And let's go back to the console and check if they are all created properly. I'm going to go back to my console, go to the EC2 section, and go to my load balancer. Okay, so we do have our load balancer created, and you can compare these two load balancers. It should have almost the same configuration because we did the same configuration using our Terraform. And let's check the listeners here. Okay, we do have 2 listeners, and the rules are saying whatever the traffic comes in, forward it to this target groups. Let's check out the target groups. If I go here, I should have the target group created, and we have the health check to be configured to whatever the requirements that we have specified there. And that's pretty much it. So we have configured our first part in our architecture, which is the load balancer setup. And in the next lesson, we are going to configure our application servers and its dependencies. Okay, I'll see you there. Bye-bye. Hello and welcome back. So in the previous lesson, we have configured our load balancer, our target groups, and our listeners using the Terraform. And in this section, we are going to configure our launch configuration, our auto-scaling groups, and all the scaling policies, etc. Using Terraform. So let's get started. So the first thing that we are going to need to create is the launch configuration so that we can hook that up to our auto scaling group. So let's go to our Terraform documentation and search for launch configuration. Under EC2 resources, we want to select the launch configuration. And here there are different examples that you can choose from and all the different options that you can provide to your launch configuration. So I'm gonna choose a example from here. This is going to be a basic example, and we'll be adding our parameters to that by checking the launch configuration that we have created through console. So first thing that I want to do is I want to give this a name. I'll call this app underscore launch configuration underscore. I'm just gonna give it a name of I'm just gonna give in the date 01 underscore, I'm just gonna use dashes instead, 07 2018, and I'm gonna give this a name as the same as the resource name here. Copy, paste. Okay, so we need to go back to our console to figure out the image ID, which is going to be our AMI ID. So I'm going to go back to my EC2 console, go to the launch configurations. Here you can find all the settings that you have configured for this. So I'm going to copy in the AMI ID from here. And okay, so like we've created for the other variables, I'm just going to create a new variable here for the AMI ID. I'm just going to paste my AMI ID here. So I'm going to copy and gonna cut this, put it here, call this AMI ID, extra line, and I'm going to use it here. So I'm going to call this var.ami ID. I just want to use t2.micro. This would give me, so I'm just going to go here and check all the other stuff that I need. So I need an IAM role to be assigned. So I'm going to go back to my documentation here and see how I can configure this. So this is going to be instance role. Copy this, paste it here. So my instance role would be our instance role part. So I'm gonna copy this from here and put it here. Okay, so the next thing that we need is the key pair name. So I'll go back to the documentation, copy the key name here, put it here. So that's going to be our VPC test KP. I'm just gonna confirm it. Okay, copy that, paste it here, and we need the next thing that we need is the security group. So I'm gonna go back here and copy this. Okay, so this is going to be a list of security groups. So we can put it here, and this is going to be a list of security groups. So first thing I need to do is like go back here, copy the security group, and let's create a variable for this guy. So I'm going to copy this block, make a variable named public security group. We need our application servers to be hosted in public security group, so that's why we choose this one here and put the security group here. So var.public sg. Okay, so one more thing that we need is the user data. So we need this user data so that we can copy our build whenever we boot up a new instance. So the way we do that is we are going to create a file at some path, and then we are going to give that path to as a reference to the user data. So I'm just going to call this user data, and inside this file I'm going to copy the user data that we have created here. So copying this one, pasting it here, and save. Okay, so here the way you're going to refer this is so this is a file, so I'm just going to open this as a file, and I'm just going to give this a path called $var.user. Oh, I need to create a variable for this path, so I'm just gonna go here and just call this user data path, and then give the path for this and call this user data.txt. Okay, so the one thing that you need to do is you need to add another slash because it doesn't recognize it with the single slash. You need to escape these slashes. So I'm just gonna add extra slash. Once you have the variable, you gonna refer that here as var.user data path, and you're going to close these brackets, match it, and actually you need to open this as the curly brace here, and you've closed this file one. You're going to close the curly brace, you're going to close the quotes there. Okay, so we now have the launch configuration ready, and as we didn't change any storage or anything like that, so I think we're good to go. Let's go ahead and run this in our PowerShell. Let me open up the one in that folder. Okay, so let's try running this. So we're gonna do Terraform planned. Okay, so this is saying the duplicates found, variable names must be unique. Oh, maybe I did a typo here. Did I do a typo? Public ISG. Oh, why do I have two AMI IDs here? Okay, so I'm gonna take this off from here, and I'm gonna try Terraform plan again. So it's saying public SG is duplicate. I'll take this off as well. Okay, so now you should be able to see that it's trying to add a new resource, which is our launch configuration. So if I do Terraform apply, this will create the launch configuration for us. Okay, so I just gonna have to give a confirmation. Okay, so now we have our launch configuration ready, and in the next lesson we are going to create our auto scaling group. So that's it for this lesson. I'll see you in the next one. Bye. Okay, so now in this lesson we are going to create the auto scaling group using Terraform. So let's go to the Terraform documentation and see what we need. So I'm gonna search for auto scaling groups, and under EC2 we have to search for the auto scaling group. So under this you'll find several examples. So I am going to choose the example of, I just need a simple example. Okay, maybe I can just copy this guy. So let me see where this ends. Okay, so I'm gonna copy all these and paste it in our configuration file. Okay, so first thing is I want to give this a name as app underscore ASG underscore prod. And okay, so the availability zones would be our subnet availability zones. So here we can just say variable, we need our, what do you call this, ASG AZs, and we'll give this as default. This is going to be a list of AZs, so we need two availability zones. So to get the availability zone info, we are going to go back to our console and go to auto scaling groups. We're going to choose these two AZs. I'm just going to copy here, put quotes around it. Okay, so I'm going to use that variable in here. So instead of this, we're going to have the variable var dot ASG AZs. Okay, so the name of the ASG is going to be app underscore ASG underscore Terraform underscore prod. So this is just to differentiate between the other load balancer, the other auto scaling group that we have created, and the Terraform one. So I'm gonna give the max size as 5, min size as 2, desired capacity as 2, health check grace period we'll leave it 300, and we need the health check type to be ELB. I don't think we need a force delete here, and we don't need any placement groups because we're just creating this normally under the load balancer. The launch configuration that we are going to use is the one that we have created here, so we have to give the name of this resource. So this is going to pick it up directly from here, and The initial lifecycle hook. So we don't need any lifecycle hook for now. So I'm just gonna take this off from here, and also I don't need to give all this stuff, so I'm just gonna get rid of it. Okay, so the other important thing that you need to do is you need to hook this up to a specific load balancer. So the way that you're going to do is you're going to go here and search for the target group example. So you're going to say, okay, so you need the target group ARNs here. So you're gonna go here, and this is going to be a list. So you're going to give a list, and what you're going to say is you're going to get the ARN for your target group. Okay, so the same like you've done in the load balancer listener, you're going to copy this part and put it in here. So now you're saying you need the target groups ARN for this specific target group. So whenever a autoscaling group launches a new instances, it assigns that new instance under this target group. Okay, so the next thing that we need is we need the termination policies to be the oldest instance. So I'm gonna go back here, copy the termination policies, and this is also a list. So we're going to put in here and going to give this the oldest. Let me copy this from here. So I'm going to give this as the oldest instance. Okay, so the other thing that we need, we got the launch config, we got these settings. Okay, so the other thing that we need is the subnets. So let me go back here and search for the subnets. Okay, so the subnets are, let's search for this. Okay, so we are going to choose the VPC zone identifier to specify our subnets. So this is going to be a list. So this is going to be here, and we need to add the subnet IDs in a variable. So I'm going to create a new variable, and this is going to be public subnet IDs, and let's go to our console to get our subnet IDs. So you can get the subnet IDs from here, copy paste in this guy, mark it with the quotes, and use this variable in your autoscaling group. So just need to, okay, it's already a list, you can just directly call this as subnets. This is public subnet IDs. Okay, so I think we got all the basic stuff that we needed here, and we just need a few tags. We're going to say this as environment, give this as production, and we are going to propagate this at launch. We don't need to give any time out, and let's run this and see what we get. Okay, so to do that, we're going to go back to our PowerShell, and we are going to do a Terraform plan. Okay, so we have some error here. So it's saying it can't find the variable. Oh, we didn't do var dot. Okay, so now okay, so something got messed up here. Identifiers. Okay. Something's not right. So let's copy that part again. So going to this. Oh, it's just identifier. Okay, so let's run this again. Okay, so now it will test whether it will check what resources it needs to create. So it's going to create the ASG. So I'm going to do Terraform apply. And give a confirmation. So I'm gonna pause the video here and then come back once this is created. Okay, so now we have our autoscaling group created with the Terraform. So we're going to go back to our console and check if that got created correctly. So I'm gonna go back to my console here and do a refresh. Now I should see my autoscaling group that's been created by the Terraform. So now not only this created the autoscaling group, it also started to launch the instances. Now if I go to my running instances, you should see the two instances that were created in the earlier lessons and the two instances that are getting created now. So if you see, these are the two resources that it's getting created. And if you notice here, we didn't get the name tag applied here, so we can go back and add that to our Terraform script. So I'm going to go back here, check what tag that we have added here. So we have added, so we are missing the name tag here. So I'm just gonna add the name tag back to in my Terraform script. So copy the name tag here, paste it, give this name. This is application production. Just making up the name here just to differentiate. So now we should do a Terraform plan again. Now this is going to tell us that it's going to add a new tag, and let's see what it comes back with. So it's changing the autoscaling group with the number of tags to be 2 now, and the new tag is going to be the specific tag that we are adding, the name and application production. So to apply that, we are going to run Terraform apply, and we are going to give it a confirmation to run it. Okay, so now that we have changed this is not going to take an immediate effect. It definitely adds the name here, but the instance itself will not get the name propagated. But the next instance that is going to be launched from this ASG would have that new name tag coming in. Okay, so I believe this instance is up and working. I'm gonna go to my load balancer and try to run this URL. First, let me check if this target is actually healthy. So I came here, I can see the 2 new targets getting assigned to this target group. So I'm gonna go back to my load balancer and copy the DNS and run this. Okay, so I do get back my response from the production server application, and as you can see, we have configured it everything just via the Terraform. And now we can save this Terraform and share it with your team members, or you can store this in your version controlling, and you can recreate any environment that you want just by changing these variables here, because this is what defines where it needs to be launched and stuff like that. Once you change this, you can have the exact same infrastructure getting created in some other environment that you want. That's it for this lesson, and in the next lesson we are going to configure our alarms and scaling policies. So I'll see you there. Bye bye. Hello and welcome back. So in this lesson we are going to continue where we have left off in the previous lesson. So here we are going to configure the notifications for our auto scaling group whenever some scaling activity happens, and we are going to configure some CloudWatch alarms, and we are going to tie it to our auto scaling group, so that whenever the alarm gets triggered, the auto scaling group has an action to respond to whether to scale up or scale down based on the alarm that's getting triggered. So let's get started. So the first thing that I want to do is like add notifications whenever some scaling activity happens in our auto scaling group. To do that, we need to go back to our Terraform documentation. So you can search for auto scaling _ notification. Basically what we are doing is, if I go back to my AWS console here into auto scaling group, if I look at the auto scaling group that we have created using console, here under notification section, we have the notification which is auto scaling activity notification. And what's happening is, whenever there is launch, terminate, fail to launch, and fail to terminate, whenever these events happen, there is a notification that's getting triggered. So we are going to create the same thing in our Terraform. So let me go back to the documentation here. It's real simple. I can just copy this example from here, and I'm going to paste it in my Terraform script. I'm gonna give this notification saying activity _ notification. I'm gonna give ASG _ activity notification, and here what we need to give is like, what auto scaling group are we tying this notification to. So we're gonna tie this to the auto scaling group that we have created here. So I'm gonna take this off, and this should be replaced with this app ASG prod here. So I'm gonna copy that and replace it here, and now we have our auto scaling group name here. And on what conditions do I need to trigger the notification? So in this scenario, we need a launch, terminate, launch error. And if I see in my console, I also have I have 4 things here. So I'm gonna go back to this to check like what the references that I can make. So I need to go to the AWS documentation to find all the possible options. So we have EC2 instance launch, instance terminate, instance launch error, and we need to copy this EC2 instance terminate error. So I'm gonna copy that and then add it to my auto scaling, and this copy paste here. And that's pretty much it. The next thing that we need to do is like, we need to get the SNS topic ARN. To do that, I'm gonna go back to my AWS console. If you want to create a new one, you can always create a new one using Terraform, but I already have that created in my previous example. So I'm gonna go to my SNS topics, and I'm gonna copy that ARN from here. So that would be going to topics, and we're going to use a auto scaling group activity notification ARN. So I'm going to copy this and I'm going to paste it in. Actually, I'm going to create a variable for that, so that I can change it if I want to change the environment. So variable auto scaling notification ARN, and I can create default equal to, and I just need to cut this from here and paste it here. I think I deleted the closing price. Okay, So now that I have this, I'm gonna go to my auto scaling notification here, and instead of this I'm gonna do var dot auto scaling notification arn. Okay, so now let's go back to our Terraform and I mean the PowerShell and try to run this. So I'm gonna do Terraform plan, and let's see what this gives us back. Okay, it is kind of checking. Okay, so it is saying that it's going to add one resource, which is our new notification to our auto scaling group, and I'm okay with that, so I'm applying that to my infrastructure. So I'm just gonna do Terraform apply, and I'm gonna give a confirmation of S once it is ready. Okay, so it is ready, so I'm gonna give a confirmation yes. Okay, cool. So now that this has completed, if I go back to my EC2 and check my auto scaling group that we have created using Terraform, we can see that the auto scaling group notifications has been added here. Okay, so now we have that, and the next thing that we need to do is we need to add some scaling policies so that we can scale up or down based on whenever there is some activity happening, like high CPU or high latency in the load balancer, something like that. So we're gonna configure the same thing, which is we're gonna do a high CPU scale up, and we're gonna do a low latency alarm to scale down. So let's get started. So I'm gonna go back to my Terraform documentation, and we're going to check for first thing is we need to create a CloudWatch. So we can see CloudWatch alarm. These are the resources which we don't want. Let's check for alarm. Okay, so we need to get a CloudWatch metric alarm, and we can see different examples here that we can use from. I'm just going to copy the first example from here, which is going to be this one. Just copy it here, go back to my Terraform, and paste it in here. So what this is going to do is, like, it's going to create a CloudWatch metric alarm. So here I'm gonna say this is going to be high CPU alarm, and I'm gonna name this app underscore high underscore CPU alarm, and the operation is going to be greater than or equal to threshold. Okay, and the evaluation periods are like I want to check for at least 5 times, and the metric name is going to be a CPU utilization, and namespace is AWS EC2, and we also need to add the dimension so that it is just doing it across the instances in the auto scaling group itself, and not the entire CPU utilization of our production infrastructure. So I'm going to check it for 60 seconds, and 60 seconds and 5 consecutive periods, and the average, and the threshold is if it is more than 80%. And I'm just not gonna do any insufficient data actions here, but instead I'm gonna go here and check for my dimensions, which is going to be my auto scaling groups dimension, and I'm gonna add the dimension here. So what this is saying is whenever this alarm happens, it just calculates the average CPU across the instances which are attached to this auto scaling group. So here we just need to get the name of our auto scaling group and put it here. Okay, so the next thing that we need is what happens when this alarm gets triggered. So to do that, first we need to get the scaling policies. So let's go, let's open up a new page of this guy and search for auto scaling. Okay, so we can see auto scaling policy here. So we can just choose one of the examples from here. So I'm gonna choose auto scaling policy. Okay, so this is going to give a name, policy type, target tracking, resource ID, scalable dimension. Okay, let me search for action, auto scaling target. Okay, I think we are in the wrong documentation here. We need to this is app auto scaling policy, so we need to search for auto scaling group policy under EC2 resources here. So I'm gonna go here and choose the auto scaling policy, and here I need to just copy this example, and I'm gonna paste it here. So I'm gonna say auto scaling policy. This is app scale up policy. So what this is going to do is, I'm just gonna put app scale up. So what this does is, whenever something triggers this, it's going to add a new instance, which is going to be, we're going to add one new instance, and the adjustment type is change in capacity, and the default cooldown period is when should the next scaling activity happen after this particular scaling. So we're gonna put 300 seconds, and on what auto scaling group does this need to take the action on. So I'm just gonna choose the my auto scaling group that we have created here, copy the name there, paste it here, and the next thing that we're gonna do is copy paste the same thing again, the entire thing, and we will do a low CPU. So whenever there's a low CPU alarm, well, you could do a low latency or anything you want. It's just easy to replicate the low CPU with high CPU. So I'm just gonna do a low CPU here in this case. So we are saying low CPU if it is less than or equal to, instead of greater than or equal to, we are just gonna do less than or equal to threshold, and we're going to evaluate for 5 consecutive periods CPU utilizations, and the threshold that we are going to give is if it is under 30% average CPU across the instances in this specific auto scaling group, then we are going to execute a new scale down alarm. Oh, I didn't actually add the action there, so we're gonna add that now. First we're gonna change this. So the policy would be scale down policy, and we're going to change adjustment to -1. That is, we're going to remove the one instance from the auto scaling group, and this is going to do it on this auto scaling group. So the one thing that it is missing here is what happens when this alarm gets triggered. So there's no action specified here, so we're gonna add that part. So we are going to go back to the documentation here for the auto scaling groups, I mean the CloudWatch alarms, and we're going to give the alarm action. So here we're going to copy this part, put it under the dimensions. So whenever this alarm happens, we're going to trigger this auto scaling group policy, which is going to be this policy. This is for high CPU, so we are copying the high CPU policy, pasting it here. And for the same thing, we're gonna copy the low CPU alarm here, I mean the low app scale down policy here, and we're going to put the action. Oh, let me copy this action again and paste it here. And here, instead of app scale up, we're going to copy the app scale down policy and paste it here. Okay, so now we have our alarms configured, and we have our scaling policies, and whenever these alarms get triggered, these scaling policies would adjust the auto scaling group's capacity. So let's run this and see whether that works. I'm gonna do Terraform plan, and this is going to check what all the resources it needs to do. Okay, so we have some error here, which is auto scaling app. Okay, so we have the error saying resource CloudWatch high CPU alarm config unknown resource. Okay, so high CPU alarm, we have unknown resource, which is, oh, I think I didn't remove this guy here, and I might have done the same thing here. Okay, so I took it off from there. So let me try that again now. Terraform plan. Okay, so now we don't have any errors. It's checking the AWS to check what resources it needs to add. Okay, so it's adding 4 new resources, which is our scale up, scale down policies, and our high CPU and low CPU alarms. So let's apply that. Terraform apply. Okay, so now it's applying those alarms, and once this finishes, let's go back. Okay, I need to give the confirmation yes. So once this completes, let's go back to our AWS console and check if these resources are created. Want to do that, go to my EC2, do a refresh. So here, if I go to this Terraform here, so now you can see we have our simple scaling. We are saying if there is a low CPU, less than or equal to 30% of 5 consecutive periods of 60 seconds, then we are going to remove one instance. And same thing, if there is the CPU greater than 80% for 5 consecutive periods of 60 seconds, then we are going to add a new instance. So that's it. So we have our load balancers, our auto scaling groups, our alarms and scaling policies, everything configured via the Terraform. And now that we know how to configure stuff with Terraform, you can extend this to create your VPC, your subnets, your security groups, and you can basically spin up every single resource that you have spun up using the console via the Terraform configuration. So this really helps you to maintain your infrastructure and to document your infrastructure, so that if there is any changes that you want to make, or if you want to restore it to your previous configuration, then you always have this particular script with you. So the important things that you need to consider is, when you are saving your infrastructure as code, you need these 2 folders, which are really important. I mean, the 2 files that the Terraform created for you are very important. You need to also put this under version control. So the tf state and tf backup, tfstate.backup. So these 2 files actually keep track of what resources were created, what are the IDs for those resources that it created, and stuff like that. So it is really important that you save these 2 things, so that you can change your existing infrastructure and update your resources. So that's it for this section, and it was really a fun thing to configure our infrastructure using Terraform. So I'll see you in the next one. Thanks. Bye bye. So this concludes our Terraform and infrastructure as code section, and let's do a quick recap of what we have done so far. I've really enjoyed this section of the course, and I think we have really covered a lot of ground here. We started off by learning about what Terraform is, and then we did a Terraform setup, and then we have created our IAM user, and we have installed our AWS CLI. We've configured our access key and secret access key, and then we have seen how to use Terraform and how to browse the documentation to get started. Then we did a Terraform init, and followed by we configured our application load balancer. We have created target groups, listeners, everything using Terraform, and we have seen like the different phases of Terraform, like Terraform init, Terraform plan, and then Terraform apply, so on and so forth. And then we created our auto scaling groups, our scaling policies, our CloudWatch alarms, and basically we have automated everything that we have done manually in our previous lessons. So
I really hope you guys enjoyed this section, and if you have any questions about any part where you didn't follow, you could just comment in the comment section, and I'll try to answer your uh, doubts, and then we can take it from there. So that's it for this section. Let's see you in the next section. Thanks. Bye bye. Hello and welcome back. So now that we have created our production infrastructure using the AWS console, and also we have learned how to use Terraform to configure our infrastructure and maintain it, now is the one big and important topic, which is DevOps. How do you manage your infrastructure now? Like, how do you keep track of what's going on in your production infrastructure? You we did configure our emails as our point of notification when there is some auto scaling happening, or when there is some high CPU or low CPU, high latency alarms, these kind of things. But instead of having it on the email itself, how would it sound if we get notifications of those scaling activities and anything that's happening in the cloud directly into our Slack? Most of you might have already used Slack. For those who don't know Slack, it is basically a messaging application that most of the companies use. It is very good for team communication. You have different integrations that you can choose to configure with, and basically it makes communication very easy and effective when in terms of communication between the teams itself. So the idea here is to get the notifications that we are getting in the AWS, to forward those notifications directly into the Slack channels, so that all the team members within the Slack can subscribe to those channels, and then they can see what's going on in the cloud, and they can take an action if there is something critical that is going on. You can have your SNS topics configured in your application itself with like exceptions, or if there's some errors that's going on, if there's some crash reports that you want to collect, you can send all those information directly into the Slack when you throw a notification to an SNS topic, and we can connect that SNS topic to trigger a Lambda function, which is going to forward that to the Slack. So let's get started with the Slack. So to do that, first we need to go to the slack.com, and if you already have a workspace here, you can use that. I'm just gonna create a new one, and I'm just gonna give my email. So it's going to ask me for a confirmation. Let me just copy that from my Gmail. Okay, so I entered those numbers that I got in my email, and then it's asking for my name, and then I'm just going to give Esrathan here, and I'm going to continue to my password, and I'm just going to choose this for education purpose and how big of a team. Just choosing the minimum. This can be configured according to your needs. I'm going to create the group name. So I'm gonna use the group name as my Udemy course. So my Udemy course.slack.com is going to be my endpoint for Slack. I'm just gonna hit I agree. Okay, so you can invite other team members that you want to. I'm just gonna skip it for now. Well, Slack, if you have work Gmail or anything configured in your Office workspace, you could always use that because the Slack also supports SAML integration, so you can have your
Active Directory users have a direct access to your Slack in the paid version. So in this use case, we just don't need that. So now once we have our Slack open up ready, I just want to skip this tutorial. So the first thing that I want to do is like I want to create I can use this general channel to post my notifications to. So first thing we need to do is like we need to create a webhook URL. So what a webhook URL is, basically that URL, whenever someone posts to that URL, it's going to come, it's going to send a notification, send a message to a specific channel. So to create that, we need to go here and do manage apps. So under manage applications, you can have several different integrations. Like you could have your Jira integration, you could have your there are like many different applications that you can integrate it with. If you browse the app directory, there are so many apps that are getting integrated with Slack these days. You could also integrate your Google Drive or your all the apps that Google offer, that kind of stuff. So for our purpose, we are going to use the custom integrations. So I'm going to choose the custom integration here. Okay, before we see any custom integrations, we need to actually create an application which takes in a custom integration. So I'm just gonna hit build here, and I can just go to start building, and I can just create an application here. So I'm just gonna give this name my company AWS activity app name, and this is going to post to my the workspace here, and I'm just gonna create the application. So here what we could do is like we can create different configurations like /commands, bots, etc., but we are interested in the incoming webhooks. So I'm gonna select this one, and I'm going to activate this. So once I activate this, all I gotta do is like create a new webhook for this workspace, and I'm going to post it to the general channel, and I'm going to hit authorize. So once I hit authorize to that, I have the webhook URL. So whoever posts to this webhook URL can post this specific channel. So now that we have this incoming webhooks ready, the next step is to go ahead and create our Lambda function, which can send notifications to this specific URL. So I'll see you in the next one. Bye bye. Hello and welcome back. So in the previous lesson, we have created an incoming webhook in our Slack, and in this lesson, what we are going to do is we are going to create a AWS Lambda function, and this Lambda function will trigger a notification to Slack whenever there is some activity that's going to happen in our AWS. So let's see how we can configure that. So to do that, we need to go to our AWS console and go to the Lambda service. So inside Lambda, what we are going to do is we are going to create a function. So basically the AWS Lambda is a serverless function where you can just write your code and you can configure your triggers to trigger that function, and that function gets executed, and you can have different sets of actions that you can perform within that function. Like maybe you want to change something in your AWS ecosystem, or you want to post something to Slack or something like that. So it is very easy to configure, and it is very easy to manage Lambda functions, because you don't have to worry about the server configuration and where you want to host this application, stuff like that. So so let's create the Lambda function that posts notifications to Slack. So here we don't need to write any function because we can choose from the blueprints. There are various different blueprints that you can choose from, but we're going to search for Slack here. Here we are going to choose the CloudWatch alarm for Slack using Node.js. the basic thing that we need to do is give this a name. So I'm gonna say Slack notifications lambda, and I'm gonna create a role from the template itself, wherein the role would have the necessary permissions to execute this function, as well as decrypt the hook URL. So basically what we are going to do is we are going to encrypt our hook URL that we have created in the previous lesson, because we don't want to expose our hook URL, because if someone gets hold of that hook URL, what happens is they can post notifications to our channel, which we don't want. So that's why we want to protect our hook URL. We are going to encrypt it. To do that, first we need to give this a role name. I'm just gonna say Slack lambda role, and I'm going to just choose the KMS decryption permissions. And what we are going to use is we are going to trigger this function whenever there is a SNS topic gets triggered, the auto scaling activity, and I'm just gonna hit enable trigger. And the one thing that we need is now the KMS encrypted hook URL and the channel where we are going to post. So we do know that where we are posting, which is our general channel, and the encrypted hook URL would be the encryption that you're going to create now. So to create an encryption URL, what you need to do is go to your IAM service, and under your encryption keys you can create a new key, and you can call it, before that you need to select your region, because we are in EU West. You have to choose the EU region here, and now here you can create a new key. You can call it Slack lambda CMK, this is a customer managed key, so we are putting CMK here, and then I don't need to give any tags here, so I'm giving access to myself to manage, and I'm giving this account, and I just need to hit finish here. So once you have this key, what you need to do is you need to go to your PowerShell and run a CLI command that would give you the encrypted URL. So to do that, what I'm going to do is first I'm going to go to the AWS documentation. AWS, I think the URL is encrypted here itself, placed here on how to use this. I think I'm just gonna figure it out from here. So you can use AWS KMS encrypt, and let's see what this gives us. Okay, so there is this one. It needs key ID and it needs the plain text. Okay, so let's try with that. So we're gonna give the key ID. So this is going to be our key that we just created, so I'm just gonna use this key ID here, and we can paste it here. And the next thing that we need is the plain text, which is our hook URL itself. So if you read the instructions here, it is saying you just need to create a encryption here with just the URL and not the HTTPS or any other protocol that it specifies. So I'm gonna go back to my Slack incoming webhooks and copy my URL, and I'm just gonna copy it from here because it mentioned that we don't need the protocol. So I copied that and pasted it here. So now once I press enter, it's going to give me a encrypted. So the basic thing that we did here is, like, we didn't specify the region, so I'm gonna specify the region EU West 1. Okay, so now we got the encrypted ciphertext here. So what I'm gonna do is basically copy this entire thing into a notepad session so that I can extract this. basically select this entire thing, open a notepad, paste it in here. So basically this is our ciphertext. So if I just expand this, I can see that this is in the next line. So I'm gonna get this back, so this is all now one single string. I'm gonna copy this and paste it in my lambda function here, and I can just now now I can just do a create function. Okay, so now we have our Slack notification function created in the Lambda. There's couple of things that you need to change here. Basically, this function is intended to just send the CloudWatch alarms, but we want to use this as a generic one for both auto scaling notifications as well as the CloudWatch alarms. So I'm just gonna remove some parsing elements here so that we can send a generic message. So if you go to the process event here, so basically what this is doing is it's parsing out the message and just pulling out the information like alarm, new state, old state, etc., which we don't want to do. What I'm gonna do is const str message, which is I want to convert this as a string. So I'm gonna do JSON dot stringify of this message, and there's an extra brace. The next thing that I'm gonna do is like I'm going to just put this str message here, what did I do, str message here, and then I'm just going to take off the extra things that we don't require. Okay, so now that we have this, we can just save this, and I'm just gonna use a test event to see if this is going to work. So I just googled for SNS test event, so I'm just gonna give this a name, test Slack. Test event, and I'm going to just create this, and I'm gonna hit the test button here to see if we are getting the response back in the Slack. Okay, so we do see our notification coming through, which is our test alarm that the test event that we have configured in the Lambda. So now let's go back to our the auto scaling group itself and try to scale up a new instance and see if that notification is getting triggered into our Slack. So let's go back to our EC2 resources, and we are going to go to our auto scaling groups, and here we'll choose this guy and we'll try to add a new instance. Let's just wait until the new instance comes up. I'm just gonna pause this until the new instance comes up. Okay, so now that we have our new EC2 instance added here, let's go back to our Slack channel and see if we got a notification. Okay, so we do see a notification coming in here for the scaling activity that we had, and like you can see, it is a it is a very good use case wherein all your team members need not go to your cloud console to check what's happening. Instead, you can get all those information and visibility of what's happening in your cloud right in your Slack channels. So I really hope that you guys enjoyed this part of the course, and I hope you can extend this example to different use cases that you might have. Some of the use cases that I think really interesting are hooking up your exceptions from your applications directly into your Slack, so that your team members can go in and track what's happening in your application. If there's something error happening, then you can have a real-time look into the exceptions, and you can try to fix those. So I hope this helps you in your helps you in maintaining your production applications in a good state. So that's it for this lecture. Thank you so much. Bye bye. So this concludes our course on setting up AWS production infrastructure and learning Terraform. I really enjoyed teaching this course, and I really hope that you all got some good info out of this, and you'll apply these concepts in your own production infrastructures that you'll be building. And if you really have any questions or any concerns about this, or if you want me to include any other topics in this particular course, you can always contact me at mail@saikiranratan.com, and I'll be more than happy to answer all your questions, and I'll make any changes to this course based on your suggestions. Thank you so much, and you can if you like this course, please do share this course with your colleagues or your friends, and spread the knowledge of AWS cloud. Peace. Thanks. Bye bye.